बाकी लोग कहाँ हैं? शुभम आणि कार्तिक, दिन वो आप लोग इधर भी है उधर भी है?
हाँ, वो वहाँ का प्रॉपर नहीं दिखा तो यहाँ से प्रोजेक्टर।
हाँ, बाकी लोग तो ये रिकॉर्डिंग होते रहता है क्या?
हाँ, रिकॉर्डेड भी देख सकते हैं।
अच्छा, ठीक है। Yeah. See now, yesterday we have discussed about a Spark. Okay, yesterday or your day before yesterday. Okay, when you use a Spark, Spark is usually used for, to process large amount of data, especially to process or analyze big data. And we know that advantage of Spark, right? There are a lot of advantages of Spark. Okay. The reason already we know why Spark, because it is speed. Okay, because it's almost 100% faster than MapReverse. It's easy of use. Okay, coding is easy. Okay, now we started with the core Spark where we are working with the RDD, which is very close to hardware. And later we started working with the data frame. Okay, like working with the like a table, rows and columns. Second, the Spark can also be used its generality. You can combine SQL. For example, you have a SQL RDD first. Already you have RDD at bottom layer. Then we have a Spark SQL. Now you are going to study Spark ML. You can also work together. Okay, Spark SQL along with Spark ML also you can work. Spark SQL along with Spark streaming you can work with. Okay, so that's a combined SQL, streaming and complex analytics. Secondly, you can run on anywhere. Spark can run on anywhere. When I say run on anywhere, first of all, you can run on standalone. Because standalone में आप run करना चाहता है तो, the first you should have a like which Spark you want to run. Whether you want to run the Spark with Scala, Spark with Python. Okay, Spark with Scala anyway does not require anything. Just simply install Java framework, it will work. But when you want to work with a Spark with Python, especially, you should install your Python also. Then you have to backend, you have to have a Java framework. Then top of that, you can install a Python. Okay, especially Python if you want to install. Whether it can be with, अगर आपको Jupyter notebook चाहिए तो Anaconda is the best way, where it comes with Python plus Jupyter notebook. Otherwise, you have a command line, like a Python, how you get Python's prompt, na? So like to greater than, so that way you can write a code. Third thing is that you can install it. Then you can work with the Jupyter notebook and the Spark you can work. Only the difference is that you can use exclusively Spark cluster. Okay, you can use exclusively Spark cluster, or you can also use Spark on top of Hadoop also. Okay, one is you can use exclusively. That is, for example, I can have a separate Spark cluster, okay, where we have, that is, as I said, a cluster, when I say, is used for only computational purpose. Okay, used for what? Only computational purpose. And you can have a separate Hadoop cluster also. Okay, you can have a Hadoop cluster here. When you have Hadoop clusters, you have a Hadoop, you know that having also 2-node cluster. Okay, now here in Hadoop, what you can do, you can also process data, you can also store data. You can process data and also you can store data. Here, if I want to use exclusively for computational purpose, okay, if I use a computational purpose, so I can use this as a source. I can store data here. Okay, in Hadoop cluster, this is a Hadoop cluster. And this is Spark cluster separately. Okay, so you can process the data here, and for especially for machine learning or for even you can do machine learning here also. Like using MapReduce program, you can write a program of everything, and you can do that as well. Or you can just process the data and you can bring data over here only for analytical purpose. Okay, you can bring this data for an analytical purpose. Or if this is on a Hadoop, on top of Hadoop, like any ecosystems. Okay, like suppose if you have a Hadoop example, you have a Hadoop. This is a Hadoop, and on top of Hadoop, you know that there are ecosystems we have. Okay, so we have an ecosystem. One of the ecosystem, this can be also your Spark also. You can keep on Spark as well. Okay, ecosystem is like, you know, that processing tool like a pig we have. Here we have a Hive tool, and at par of pig and Hive, you can also keep a Spark here. Okay, you can keep also Spark. One of them. If you want to keep on top of Hadoop, yes, you can keep on top of Hadoop Spark. Okay, so it uses same architecture. Okay, here this you know, in Hadoop, what is this one? Primary node is called a name node. Okay, name node. Okay, if you install on top of Hadoop, so this is also acting as a Spark master. Okay, this is acting as a Spark master. Okay, and your driver program is associated with the name node. Our job tracker is associated with the name node. Now, since it's a data node, okay, and this is also acting as a what? A Spark workers. Huh?
Spark workers.
Spark workers. This can be a, if suppose if you keep a Spark on top of Hadoop. Okay, in Hadoop, you know architecture. Name node we have, data nodes we have. Again, on top of that, if you keep a Spark also, like Hive and Pig, so now name node, if that node, primary node is also acting as a name node, it is also acting as a Spark master. Okay. Data nodes are acting as a Spark workers. It is also acting as a data node, and also it is a Spark workers. No. Two processors. These are all processors. Okay, processor will get initiated. Okay, here name node is one processor. Data node is also one processor. Right. So there can be a multiple data node so that multiple processors will get initiated. कितना आप अगर आप समझो, if your laptop is 5 cores, one core can be considered and 5 node may be having the same IP address. So if you are having only one machine, all are having only one address. Okay, local host or the local address. But different pipe, your machine can support up to 5 cores. So it means that logically you can divide your machine into 5 times. Otherwise, earlier, you know that 20 years back, we used to have a laptop with single processor. Okay, now we are having a laptop with multi-processors. Okay, today you have i13, i14, whatever you have, right? So you have a dual core, even triple core, multi-core processing. So as many processors you have, it means that it's like a one CPU. One processor means one CPU. Now, if it's a 5 processor is right, okay, in the 5 processor machine, 1 processor, but the address is same. See, because of only one laptop is there, laptop IP address is 1. But how do you differentiate these 5 cores? You can assign a different ports. Okay, you can local host port 1000 can be act as a name node. Local host 5001 can act as a what? Data node. So ports are different here. Okay, so it means that you have 5 different ports you can run slots. Agar now when you push data here, so logically data distributes on all nodes. All of the cores, and these cores are processing parallelly. But since you have only one laptop, memory is one. You cannot divide memory. You cannot divide disk also. Disk is also one. Memory is also one. All 5 cores or 5 processors are sharing your memory and also sharing disk. Right. So this is what we call it as a semantic multiprocessor. Okay. It means that when you go for this, I think I explained this example. If you see this, okay, you have only one machine. Machine is only one. But I said you have a common 5 processors. Okay, processor 1. This can be a processor 2. This can be a processor 3. This can be a processor 4 and 5. Okay. All are sharing same disk. This is your disk. Okay, and all are sharing common memory also. Memory is also common. Let's take it's your laptop. Now, this is a disk. Common disk is there. You cannot divide the disk. Common memory is also there here to process because all are. Now, when I read a data, either data I can read from external source or I may have a data here. Suppose if this data, if I want to process, okay, if I want to process this data, if you, in this laptop, for example, if you install either Hadoop or Spark, one of them, so this can act as a what? A name node. Okay, this can act as a data node. Okay, data node here. All are data node. Okay, these are all what a kind of a logical division. Right. So now, suppose if you have a data, if you are going to pull a data, so data you push through this. This will get distributed across all nodes. Okay, it will get distributed across all nodes. Right. Because this all nodes are a common disk is there, all are sharing common disk. Right. Now, for example, if you submit any job, so where are you submitting? Now you as a user here, okay, you as a user, you submit a job. Okay, when you submit a job, you submit job to name node. This job replicates across all nodes here. Same job. Okay, it is parallelly, it replicates across all nodes. Then parallelly, this job is processing. Parallelly, this job is processing. But you have only one node. Physically, you have only one machine. Okay, physically, you have only one machine. But these are all what? Logical CPUs. 5 CPUs are there, logical CPUs. Now, this particular, since your laptop is supporting up to only 5 cores, I cannot extend more than 5 cores because that is only maximum capacity. That is the limitations with the SMP, semantic parallel processing. Semantic parallel processing. One is you have maximum 5 cores only because your laptop is supporting up to 5 cores. You can go up to 5 cores. So if your laptop is supporting only 32 GB RAM, okay, when you have it, when it supports only 32 GB RAM, you cannot install 64 GB RAM, right? Even if you install 64 GB RAM, your operating system recognizes only 32 GB RAM. Same thing with hardware, your hard disk also. If your hard disk is supporting only 500 GB, and if you put even 1 terabytes of hard disk, it doesn't support. It recognizes only what capacity is only that much. It recognizes only 500 GB. When 500 GB is waste. It is not recognizing, it doesn't use also. Here, even though 64 GB RAM, if you put it, it doesn't recognize. It has only capacity of recognizing only 32 GB RAM. So that's what limitation is what you suppose if your data, suppose if you have, since you have 5 processor, it is possible to process, say, for example, 100 terabytes of data. Let us example. Now, if your data increases from 100 to 500 GB or 500 TB, what happens that it takes more time, right? Suppose if that 100 terabytes of to process 100 terabytes of data using 5 processor, if it takes say 10 hours. And now if I get what same infrastructure is same, but my data size increases here. How much time it takes to process 500 terabytes of data? 50 hours it takes. Okay. Now today data is growing like anything. So obviously I have to either extend this machine from 5 CPU to 7 CPU or 10 CPU. Okay. If it supports. But mine is already it is supporting only up to 5 GB, 5 processor I said. Okay, now what I can do that I can add one more machine like this. One more machine like this I can add here. Okay, physical machine. Or even if required, I can also add one more machine. Okay, now these machines are integrated. Okay, these machines are what? Integrated. Using, okay, one engine called a MPP engine. MPP engine, massive parallel processing. Okay, it's again one processor which will get initiated. Okay, then your data node is here, already name node is already here. You don't disturb to name node. We have 4 data nodes. Now, whatever nodes are here, so these are all considered as a data node only. Okay, these are all considered as a data node. Earlier, because when I am replicating same machine somewhere else, so I only in one cluster, only one name node, only one Spark master. But you can add only data nodes. You cannot add a name nodes. Name node is always only one. अगर मेरा project चल रहा है with one project manager, I can add a team members. I cannot add project managers. Okay, so my name node is one, but because of my data is increasing day by day, so I can go for what? More like this. Okay, so as I said, this is called an SMP. Okay, this is called an SMP. SMP means semantic parallel processing. Okay, this is also an SMP. This is also SMP. Right. So union of SMP is called MPP. Okay, that is a MPP means union of MPP equal to, okay, union of I can say SMP union SMP. Okay, SMP union of SMP is called MPP. I can add as many nodes I want, but they are all adding as a data nodes or a Spark workers. Okay, now since you have 5 nodes here, the data, whatever data you read, it distributes across all nodes. Agar now 15 node hai to the same data will get distributes here also. 15 nodes. Okay, so suppose if I give 100 terabytes of data, which was taking only for 10 hours for say 5 nodes, and now I'm having a 15 nodes. So how many hours it takes? Maybe 3 hours. Okay, that is 10 hours divided by 3. One machine is taking say 10 hours. It's like this. If I added 2 more physical machines, it may take what 3 hours only to process. So here using MPP engine, I can add as many machines I want. Okay, this is what the advantage of Spark. Spark or Hadoop. There's no limit to add. There's no limit to add a number of nodes here. Right? So here, whenever you use, it will just push, distributes, and this, even if you submit a job, the job is replicating across all nodes. Here also across all nodes. Here also across all nodes. Okay. Now, for example, if I create an RDD, simple example RDD, if I create, it creates, suppose if you have created RDD, it creates here also, here it also it creates, here also it creates, only one RDD. This somewhere else internally they have linked. Okay. So, but this is only one RDD, RDD1, RDD1, RDD1. Distributing across, means some memory of all CPU will occupied, some memory of all CPU will also occupied, some memory of all CPU also occupied. Okay, that's what an RDD means. It's a distributed data set. It's a data set like an array, but it's distributing across all nodes. Now data, when I'm having a data, say that this one RDD, you don't have any data structure here. You don't have any data structure. तो डेटा स्ट्रक्चर के लिए हम क्या कर रहा हूं, आरडीडी का साथ वी आर एडिंग अ डेटा स्ट्रक्चर. इन द बिगिनिंग वी हैव आरडीडी ओनली. सो आरडीडी के साथ में क्या किया, डेटा स्ट्रक्चर ऐड किया. व्हेन आई ऐड अ डेटा स्ट्रक्चर विथ आरडीडी, दैट इज कॉल्ड डेटा फ्रेम. Data frame. Data frame means the schema plus RDD. Back end you have RDD and top you have a data structure also. That's called a data frame. Now today, whenever after 2.0, whatever Spark you are using, you are working with only data frame, not RDD. Internally RDD get created, but here we were working with only RDD. If you go to before 2.0, 1.6 and below, 1.6 and below, we were working with exclusively on RDD. Because that time there was no feature which was introduced as a data frame. Later they introduced a data frame on top of a core Spark. Earlier we had only core Spark, where we were working with the RDD. Later, because of, as I said, to address larger audience, because you make it easy for them, so they introduce a data frame. Data frame is, I think, since yesterday you are working with the data frame only. Okay, since you are working, because you know that you are, whatever file you read it, you have a data structure also, like column name, data type, and all those things. And in whichever column you want to access, you can access a column, like say using select statement. If you want to drop a column, if you want to select a columns, if you want to drop a rows, or you are working like your tables only. Okay. So today we are clearly working with say data frame most of the time, because data structure currently no one works. That's why you can run Spark on everywhere. This architecture we all know in the beginning, we have only core Spark. Depends on requirement. First they introduce a Spark SQL, okay, to address larger audience. Now, because of data is coming, started increasing heavily. Okay, because social media is also introduced. When the social media introduced, now I wanted to just pull the data continuously, which is coming continuously. So in that case, again, another requirement has come. they introduce what a streaming part. Okay, streaming part they introduce Spark streaming. This is a API which will connect data coming continuously, like 1 milliseconds data it will accept. So far, what we have done with the Spark SQL or Core Spark, we were all working with the batch, because मेरा फाइल है, पेज व्यू का फाइल है, मैं अपलोड किया, वो अपलोड करने के बाद मैं एनालिसिस कर रहा हूँ. I don't want to do this. As data comes in, I want to process immediately. Okay. So that processing that we want maybe in terms of milliseconds. I can set a timer. Okay. So suppose, for example, there is a log file. Web server is there. Web server logs are generating continuously. Okay. Logs are generating continuously. So now when the logs are generating continuously, I can set a timer like every 1 minute. Whatever log amount of data is generated, I want to pull it. I want to analyze immediately. The moment I analyze it, again, next 1 minute data I will take it and analyze it. Even 1 minute is too late. It can go to a milliseconds. Okay, it can go to what a millisecond, so that we can analyze like a near real time. It's not a real time. It's like a near real time. Spark is used for a near real time. If you want to work with a near real time, advanced than Spark, there is a Flink, Apache Flink, that can be used for a near almost real time. So here, because there is a time gap is there, it may be millisecond gap. Real time में क्या होता है? आप इधर क्या कर रहे हैं, उधर भी हो रहा है. Real time में what happened that okay, real time आप live मैच देखते रहता है ना, so उधर किक मारे तो अर्जेंटीना में इधर आएगा, आपको इमीडिएटली देख सकता है. ओके, सो अगर आप पेपर में पढ़ रहे हैं तो क्या हो जाएगा, परसों का किक मारने का आज पढ़ रहे हैं आप, राइट. अर्जेंटीना में मेसी वो किक मारा ना, सो immediately he is, the moment he kick, within few milliseconds you will see it. Within few milliseconds streaming is there, continuous streaming data is there. Okay, अगर समझे हमारे पास स्ट्रीमिंग नहीं, अखबार हम पढ़ रहा है, अखबार पढ़ने का उधर से बैच प्रोसेसिंग. ओके, वो 3 दिन का कितना न्यूज है, वो कितना मुझे 3 घंटा का कितना मैच है, वो पूरा हिस्ट्री आपको देगा. ओके, टॉस कौन किया, स्टार्ट कौन किया, कितना गोल हो गया, कितना किक मारा, वो मारा, ए मारा, होल न्यूज ही कलेक्ट्स. देन ही राइट्स, give it to you in the form of newspaper, and today you will read the newspaper. That's like a batch processing. That's like a batch processing. At a time, the data, whole data, I will take, collect it and give you. But real time में क्या हो रहा है? The moment is happening, it is knowing again. That's what a real time. Stock market is the best example. Okay, stock market is the best. They are all real time. But now Spark does not support for a real time. It's supporting near real time because we have a time gap. Okay, we have a time gap here. That's what using Apache Spark streaming, we use that actually. That's also another. When the requirement has started, they introduce a Spark part. Now you know that there's a hype called AI part. Okay, there was a hype. AI, artificial intelligence, machine learning, because everything they wanted to automation. Okay, IoT has come into picture, right? Otherwise, आप लोग गया यहाँ से हम सभी लोग गया तो फैन चलो है, लाइट चलो है. अगर आपको कल आज छुट्टी है, अगर कल तक वो ऐसे चालू रहता है, राइट. अगर उसको साथ में मैं क्या करता हूँ, उसको मैं सिंपली आई विल मेक इट एज ए स्मार्ट. वो लाइट है ना, वो लाइट को मैं स्मार्ट बनाता हूँ. स्मार्ट कैसा बनाता हूँ? जस्ट अटैच अ चिप फॉर दैट. आई अटैच अ चिप फॉर फैन. ओके, सो सेंसर से देख रहे हो, सेंसर से देख रहा है, द मोमेंट द सम ऑब्जेक्ट्स आर मूविंग, देन फैन स्टार्ट्स. इट आइडेंटिफाई करेगा वो कोई तो है इधर. अगर कोई भी नो ऑब्जेक्ट्स आर मूविंग, देन ऑटोमेटिकली फैन गेट ऑफ. सेम थिंग विद द लाइट. Okay, same thing with the light. अगर मुझे वो समझ रहा है वो there is a darkness, then automatically bulb will on. The moment some open the window, bulb will go off. Because because of this, it's an efficiency is there here. You are saving energy, you are saving power here. Okay. So we have many things are smart only today. Okay. Even if you take your cyber shot में क्लिक करने का वक्त क्या करता है, इमेज रिकग्निशन करता है, राइट. सो अगर अनलेस अनटिल यू स्माइल द फेस ऐसे सीरियस हो गया तो क्लिक भी नहीं हो जाएगा. इट एक्सपेक्ट्स दैट फेस शुड बी अ स्माइल फेस. सो पहले कैसा था, हम स्माइल करो बोलता था, करेक्ट. आजकल नहीं, तुम स्माइल करो ना करो, इट विल स्माइल ओनली, इट विल क्लिक ओनली इफ इट स्माइल. यू आर फोर्स टू स्माइल, क्योंकि देयर इज इमेज रिकग्निशन. आजकल जीपीएस है, जीपीएस उसको शूज को भी आ गया आजकल. ओके, जीपीएस चिप एडेड इनटू द शूज. ओके, अगर आप मैं यहाँ से नांदेड़ सिटी को जाना चाहता हूँ तो देयर इज अ रूट. ओके, मल्टीपल रूट्स आर देयर. ओके, अगर मैं नांदेड़ सिटी तरफ से नहीं जाना है तो मैं वाकड़ तरफ से जा रहा है तो ऑटोमेटिकली वाइब्रेट होता है शूज, क्योंकि यू आर गोइंग रॉन्ग डायरेक्शन. ओके, it is already taking you are already putting from where you want to go, so automatically taking care of that. Even in that instant, even there are some smart fridge, you might have heard. Smart fridge में हम सब कुछ रखता है. Then you don't know what dish you have to prepare. I have to just check the content of each container, then decide which dish I can prepare it. Today what happened that these are all based on that content. It will decide, so these are the content available in the fridge, this dish you can prepare. Correct. This is again smart fridge. Everything is what a smart here today. Like for example, garbage collection के लिए देखो, अगर garbage collection के लिए bins रखता है सभी तरफ से. ओके, सो एक बिन खाली है, एक बिन ओवरफ्लो है, हमको पता नहीं. वो ड्राइवर क्या देखता है, वो खाली है तो आगे नहीं जाएगा. Okay, so bin के लिए I can add a chip. Okay, it when the moment it reaches certain amount of dust, okay, so it's supposed to send a message to application. Application message should send a message to a driver. Okay, then driver go and collect the fridge. Or another best example is that your jars at home, घर में jar रहता है ना, अब रखता है कंटेनर में, जार में कुछ सब कुछ रखता है वो. ओके, समझो आप कुछ दाल रखा, दाल में एक मार्किंग है, एक मैक्सिमम मिनिमम डेंजर. मैक्सिमम है तो इट डजंट ऑर्डर. अगर व्हेन इट गोज टू मिनिमम लेवल, सो इट इज एक्सपेक्टेड टू प्लेस एन ऑर्डर. सो उधर तक में चिप है मेरा, चिप से वो व्हेन इट रीचेस टू मिनिमम लेवल, ऑटोमेटिकली आई विल पुट ए प्लेस एन ऑर्डर टू अ बिग बास्केट. ओके, यू नो दैट इट्स टेकिंग 2 days. So by 2 days, it may go to a danger level. So before it goes to danger level, you will get a 1 more pack. So this is all called what a smart. It's also called an IoT, Internet of Things. अगर मैं घर में कुछ गैस भूल गया ऑन करने का, ऑफ करने का, मैं इधर आने के बाद मुझको पता चला अरे मैं भूल गया, यहाँ से मैं ऑफ कर सकता हूँ, यहाँ से मैं लॉक कर सकता हूँ घर. Even Toyota has introduced Toyota or Ford has introduced. Okay, कार में GPS ऐड किया. क्या कर सकता है, this GPS, this car is taking all information about this route. This car is also taking information about this route. अगर जब दोनों मिलता है इधर, okay, so this car takes all data from this car and understand where okay traffic is there, आगे कैसा चल रहा है, ट्रैफिक है क्या ना है. सेम थिंग, दिस कार आल्सो पुल डेटा फ्रॉम हियर एंड प्रिपेयर अ डैशबोर्ड दैट आगे कितना तक आप पहुंच सकता है, कहाँ ट्रैफिक है, कहाँ एलिवेशन है, सब कुछ आप इधर देख सकते हैं. ओके, सो मुझे इट्स ऑल IoT, मशीन टू मशीन कनेक्शन. उनका सॉफ्टवेयर है, फोर्ड सॉफ्टवेयर से. ओके, फोर्ड गाड़ी आप रन कर रहे हैं, इधर भी फोर्ड है, इधर भी नहीं, सभी कार से नहीं लेता वो. ओके, अगर फोर्ड, दोनों फोर्ड गाड़ी है, ओके, बोथ आर कनेक्टेड टू सेम एप्लीकेशंस. सो दिस इज हैज ऑलरेडी कलेक्टेड अ डेटा फ्रॉम, सपोज मुंबई में, अगर आई मीन पुणे, वन कार इज कमिंग फ्रॉम सतारा, वन कार इज कमिंग फ्रॉम मुंबई। ओके, खंडाला में आप कहाँ से, तो एक ट्रैफिक बहुत बढ़ गया, वो डेटा ऐसा आकर मुझको मिला कतरेज में। सो आई एम कमिंग फ्रॉम मुंबई। ओके, नाउ आई नो दैट वेरी वेल देयर वाज अ ह्यूज ट्रैफिक इन खंडाला। आई नो हियर इटसेल्फ, नो नीड टू आस्क एनीवन। एटलीस्ट यू नो जीपीएस में आपको पता चलता है, राइट? अगर जूम 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 किया है तो कहाँ कहाँ रेड है आपको पता चलता है, देयर इज अ ट्रैफिक। ओके, सो वही जूम करने का आपको इंफॉर्मेशन, आपको जा रहे हैं ना उधर, उनको डैशबोर्ड आना चाहिए। सो दिस आर ऑल व्हाट आईओटी पार्ट, आईओटी, इंटरनेट ऑफ थिंग्स, मशीन टू मशीन कनेक्टिविटी। So many advanced technology have come which we never expected. Okay, हमको पहला लोग माइंड शिफ्ट चेंज के लिए बहुत तकलीफ होता है, माइंड शिफ्ट। ओके, स्टिल इन इंडिया आल्सो वी आर वेरी रेसिस्टेंट टू चेंज अवर माइंड। ओके, इसलिए हम लोग ऑफलाइन को आ रहे हैं, राइट? कोविड में बोलता था क्या ऑफलाइन, ठीक है हमको ऑनलाइन चलता है। Has anyone knows that this also happened? इसको भी पता भी नहीं था, हम पूरा शेवी हो जाएगा टेक्नोलॉजी में, right? We never knows, even today housewife who never touches mobile, she has water or he has water, even a internet connection today. Everyone knows WhatsApp, everyone knows Zoom, everyone knows YouTube. अगर छोटा मोटा पोहे भी करने को आता है तो लोग कर कर भेज रहे हैं सब्सक्रिप्शन। ज्यादा सब्सक्रिप्शन हो गया है तो मुझको पैसा मिलेगा वैसा। ओके, वैसा कंडीशन है आजकल। सो वी नेवर एक्सपेक्टेड अर्लियर, नाउ दिस ऑल टेक्नोलॉजी आर मेकिंग अस, समटाइम इट इज अ डेंजर आल्सो, समटाइम इट इज आल्सो गुड। अगर 20-30 साल का पहले आप देखा, ओके, टीवी कैसा देखता था आप लोग? हाँ, ब्लैक एंड व्हाइट भी है, ठीक है, वो भी फुल ऐसा ऐसा रामायण महाभारत हम देखता था, एंटीना घुमा रहता था। आई डोंट नो वेदर यू पीपल डिड इट, वी डिड इट। ओके, वो भी कहाँ तो राम का फेस में दिख रहा है, द्रौपदी का फेस रहा है, वैसा होता था हमारा सीन। एंड वी नेवर हैड टीवी आल्सो टिल, एटलीस्ट आई नो दैट टिल 12th स्टैंडर्ड आई नेवर हैड अ टीवी, राइट? सो हम दूसरों को घर में क्यों रिच है, उनका घर में ब्लैक एंड व्हाइट टीवी रहता, हम जाकर बैठने का, वो भी टाइम मिले तो। वैसा कंडीशन था। टूरिंग पैकेज नो वन नोस। ओके, टूरिंग थिएटर, मूविंग थिएटर, यू नो, यात्रा में इधर भी होता है 8 दिन, बाद में उधर होता है, बाद में उधर रहता है। ओपन थिएटर, ओके, वो पर्दे का, पर्दे बीच में रहता है, इधर भी वैसे देख सकते हैं, इधर भी देख सकता है हम। ओके, उसका पहले हम मूवी भी नहीं था ना, हम ये देखता था, यात्रा में आता है ना वो देखता था, वो मूवी कुछ पिक्चर आता था। डू यू थिंक दैट वी विल सिट टुडे एंड वॉच इन 5-star मूवी थिएटर? पुणे में नहीं 5-star थिएटर, बेंगलुरु में ही 5-star थिएटर। 1800 रुपए एक टिकट का, विथ फूड देंगे। ओके, रोटेशन चेयर्स कहाँ भी देख सकता है, और खाना भी मिलता है, खाने को आराम से कहो, 5-star एमिनिटीज। हम देखा क्या अभी, हम 5-star होटल में जो लग्जरीज आज बिकम फॉर यू, मोस्ट ऑफ द थिंग्स आर बिकम नेसेसरी फॉर अस, इट्स अ लग्जरी। ओके, आप लोग को द मोमेंट यू गेट मैरिड, कार इज बिकम नेसेसरी फॉर यू पीपल, करेक्ट? हमको कार मुझे लग्जरी हो गया। मेरा पहले कार था, वो भी अभी आई थिंक आई नो आई मे गो टू अ सेकंड कार, बट वो जब मैं ऑस्ट्रेलिया से वापस आ गया, पैसा लेकर गया, चलो दो मुझको कार दो, बस इतना, क्योंकि पहले कार था मेरा फर्स्ट कार। So for you it's become necessary, for us it's become luxury. Fan become necessary for you, for us it is still, it is luxury for you. AC. Okay, now fridge. हम विदाउट फ्रिज भी था, विथ फ्रिज भी है, विथ फैन भी था, विदाउट विथ फैन भी है, विथ एसी भी है। ओके, सी फॉर सम पीपल इट्स बिकम अ लग्जरी, सम पीपल इट्स बिकम नेसेसरी। अभी आजकल जनरेशन के लिए देखो आप लोग, ओके, सी वी स्ट्रगल लॉट, You people never, I think my son only. उनको क्या जरूरत, क्या घर देने की जरूरत भी नहीं, करेक्ट। अरे ठीक है यार, दो पापा का तो घर है, कुछ भी नहीं ना, वो कितना सैलरी आता है वो ही कैन स्पेंड। हम नहीं है ना, वो ईएमआई देते रहो बस, आधा जिंदगी हम ईएमआई में गया, वैसा भी रहता है। एनी हाउ, सो नाउ दिस इज व्हाट व्हेन द मशीन लर्निंग हैज कम, IoT, machine learning and all, they introduce a new ecosystems. Okay, that's called a M-leap. When it's a M-leap or machine learning, they introduce several libraries. Whatever libraries you have seen in Python, same libraries are here. Especially why I'm insisting to use Python, because Python is one of the best language for machine learning. Because there is a competition between R and Python. Okay, if you see another next slide here, if you see this small here, okay, in this case, there is a competition between Python and R. Python, if you go to 2015, okay, hardly just 30% market has captured. Okay, that time R has captured heavily, already more than 45% has captured market in 2015. 2016 ko, when you see 2016 this color, okay, Python has increased from 31% to what, almost 45% it has captured. Still that time your R was ahead. Right, R was almost 50% of market is going to capture. But when it became a 2017, it almost crossed R. Okay, almost crossed R. Today, if you want to get into an industry, Python is far, far ahead. And if you know Python, stick to Python. Python with machine learning, good demand compared to R. R is modest, but Python is more. You can use a more Python. Okay, so you can use, this is again still old report, but today is more than this, right? So again, I don't want to go to this all part. So components are there, like a driver program, like a Spark driver program, cluster manager is there, node 1, node 2, node 3. That is, say, like a Spark workers, Spark master, and Spark driver is associated with the Spark master, and executors are associated with the Spark workers. Okay, executor, what it does, run the task scheduled by the driver, store the computational result in memory, on disk, okay, and it also interact with the storage system to get a data. And there's a cluster manager, which will work on either Mesos platform or Yarn platform, and Spark. You can also work on a standalone Spark. Okay, this is all the architecture of Spark. So coming back to that machine learning part. Okay, so machine learning is a new ecosystem which they have introduced on top of a Hadoop. Now, first that's what we know, the Spark. Now we have to use a machine learning libraries using Spark. Okay, so this is what we have seen. Like a core Spark, Spark can run on standalone, Spark can run on Hadoop also, Spark can run on Yarn also. Okay, Spark can run on what, a Mesos platform. On all these platforms, you can run a Spark. Okay, now initially it was a core Spark, then they introduced a Spark SQL, Spark Streaming, Spark MLib, and graphics. Now I'm going to talk about a more of a MLib. We have seen Spark SQL, where we have created a data frame, you have performed certain transformation operations on data frame and all. Now, the one feature of Spark is a generality I told you, where you can use Spark SQL and Spark MLib together. You can use Spark SQL and Spark Streaming together. Okay, so this is the advantage we have in case of Spark as compared to Hadoop. Hadoop maybe those some ecosystems are there. What are the Hadoop ecosystems? Pig, Hive, Scoop, and all. Are you interacting? Are you integrating with together? अलग अलग है वो पूरा. स्कूप में डेटा ले रहा है आरडीबीएम से, एक्सपोर्ट कर रहा है आरडीबीएम को. फ्लूम डेटा वेब सर्वर से उठा रहे हैं हम. देन पिग प्रोसेस कर रहा है डेटा और एनालाइज कर रहा है. But some data which are in some Hive commands, through Hive command I cannot invoke pig commands, or from pig commands I cannot invoke a Hive commands. All are isolated tools. But now here, though these are all ecosystems, but they can interact each other. When you are working with the mlib, you can use a Spark SQL, like creating a data frame and all, performing a data frame operations on that. Okay. And graphics is another ecosystems. Spark powers a stack libraries including SQL, mlib for machine learning, and graphics for a graph processing. Main is what a Spark, SQL, and mlib we can get together. Streaming is also there. Graphics is also there for graph analytics. Streaming is there for a data coming heavily from the sources. These libraries can combine seamlessly in the same application. I am having an applications. What's my application here? All three applications you can combine together. For example, data is coming continuously. Okay. So for that, which application I have to use? Spark Streaming, I have to use it. The moment data coming, I want to create a data frame. Okay, here I'm using what? Spark SQL. Okay, so Spark SQL, immediately I want to do some machine learning operations. What is machine learning operation? Simple example is a recommendation. अब recommendation कर रहा है. Okay, क्या recommendation कर रहा है? Example, if you, the moment you log in into Amazon, okay, आप एक product buy करता है. The moment you buy a product, okay, means the data you are sending into a Amazon server. Because you may be placing an order, okay, you may be like this, you are the one person you are placing. Like this, there are 100,000 people are also placing an order. Okay, so when they are placing an order, okay, at back end, your order is taken as a one transactions. So the moment you place an order, okay, when you finalize your order or before just finalizing your order, so immediately it starts recommending. Okay, when it starts recommending means internally recommendation engine is running through machine learning. Through machine learning, it starts recommending. So the people who bought this particular, like a cell phone, also bought a power bank. Do you want to buy a power bank? Yes, it will add into the cart. The person who bought power bank and say mobile also bought a screen guard, Gorilla screen guard. Do you want to buy it? Buy. Otherwise, no. Then it start recommending you. Okay, start recommending you. Even Netflix online immediately recommends. The moment if you continuously watch 2 days or 3 days that your movie or that particular program, fourth day they will recommend you people who have seen this kind of a program, also seen these programs. And there are some programs which are coming which are similar to this, which are similar to that interest. Even if you watch YouTube for 2 or 3 days, some channels, you start getting even some mails. Agar aapka mail registered hai so these are the new programs which are coming. These are all on online processing here. Okay, online processing here. So this all we combine together. These multiple applications we combined together here. Now, this is what a total Spark. So what do you do in Spark? Normally, mlib. This is a total stack. Totally, when you say Spark stack, you have a Spark core Spark, Spark streaming, Spark SQL, Spark mlib, Spark graphics. Okay, so now one of them is very powerful ecosystem is machine learning, mlib. Okay, Apache Spark provides a general machine learning library. Okay. That's called a mlib. Mlib means machine learning library that is designed for simplicity, scalability, easy integration with the other tools. Yeah, I can definitely. Machine learning can be used to integrate with the Apache Spark streaming or even Apache Spark SQL. The key benefits of MLib is that allows the data scientist to focus on the data, their data problems. So now see, I may tell you only what this is what a machine learning, how we can use in a Spark. But if you ask me now, can you write a k-means algorithm? I know k-means algorithm, but not like you. Because you already spent, okay, what is k-means, how to calculate, okay, k-means algorithm, how to find out a nearest element and all those things, you know that. So you people are the data scientist. So data scientist, this become easy. Okay, rather using just Python and Spark, Python and machine learning. So Python and machine learning, if you use it, that's for a small set of data. That's a very small set of data. Now, if you use a Spark, Python, that's what a plus Spark, plus machine learning, if you use. Anyway, you know Python. Anyway, you know what say machine learning. Now you only have to have a knowledge on Spark. The same thing you put it for using Spark for a large amount of data. Earlier, आप लोग Python कैसा यूज किया? Single machine यूज किया, right? Single machine यूज किया. मैं क्या कर सकता हूँ? I can go for hundreds of machines. I can build अगर आप पे अभी free of cost है आपका machine learning. Sorry, that what is the Databricks platform free of cost है, they provide you still 2 cores, 2 machines है. अगर आपको production पे गया, I can make it 2 to 100 also. 100 nodes I can create in one cluster. I can create because that's a paid version. Okay, I can go for as many strong machines I want. They provide you. So that's what the key benefit of MLib is, that allows the data scientists to focus on their data problems and model instead of solving complexities surrounding distributed data, such as infrastructure, configuration, and so on. See, when earlier we also did a machine learning. Okay, how we used to do, I know that. When I was teaching machine learning in 2003, it's called not a machine learning, we used to call it data mining. Data mining. Okay, data mining क्या है? We are mining not data. We are mining basically information. Right? It's called data mining is a wrong proverb. It's called actually knowledge discovery. Knowledge discovery from database. Okay, that time data mining में क्या होता था? We have a structured data. Only structured data we used to mine. When I want to mine, if you want to see the definition of data mining is like finding unknown information. Finding unknown information. The one you see, normally data analyst or data reporting what क्या कर सकता है? मेरा इतना sales हो गया. Okay, now I can compare. So 2010 this much sales, 12 this much sales, 14 this much sales, 16 this much sales. Okay, in 1820 whether it's increase or decrease, only that graph I can see it. So now when I say that graph here, 2010 is this much sales, 100, 2012 is become 50, 2014 become what 200. So now this is what your reporting tool tells you, graph only. But data scientists, what they say is why sales has increased, why sales has decreased. They will answer your why questions. Okay. Now, this is what, when I want to say data scientist, why the data is, that's what unknown information. If it is known, that's a reporting. अगर आपको machine learning में आपका log तो generate हो रहा है. Okay, earlier हम क्या कर सकते थे? Log सभी we used to push into a bin. Today, that log is playing very important for me. Okay, when I take this log and analyze, I can understand what people are looking for. अगर मैं Amazon का log उठाया पूरा, okay, or today take an example of today itself. If I take any social media, Twitter, you take it, where more and more people are interacting. लिंक्डइन में देखो, लिंक्डइन में वो मैं कभी भी ओपन नहीं करता लिंक्डइन. द मोमेंट आई लिंक्डइन ओपन किया ना, आई एम वेरी हैप्पी टू टेल माय पोजीशंस दिस दैट आता रहता है वो. सो मैं सोचता हूँ, मैं घबराता हूँ इसको, नहीं यार मुझको नहीं चाहिए वैसा. सो अगर आपका ट्विटर देखा, अभी आज का डिस्कशन चालू क्या चालू है, अर्जेंटीना. व्हाट पीपल आर थिंकिंग अबाउट मेसी, whether people are thinking very glad or people are just blaming him. Okay, so people, you might have already discussed with your friend, yesterday night Argentina was a too good match, kick done by Messi was too great, it was his dream. अगर केरला को गया तो उनका वो they claimed if Messi Argentina wins the match, then I have to put Messi's photo banner in the sea. They also put the banner in the sea. More about a Messi or discussing. Now I take this data, I can analyze here. Okay, how many people are discussing positively about Messi, negatively about Messi, neutral about Messi. Okay, so this is what I'm talking about, a recommendation part. I mean, discussing about a machine learning. Earlier we did it, knowing unknown information. Knowing unknown information. That's what I think in machine learning. I don't know whether you know about what is that, which is going hand in hand. How people knows that in discount, अगर आपको डिस्काउंट मिलता है ना, buy one get one free, buy two get one free, something you will get it all. On what basis? Okay, internally they worked on data mining. Okay, आप लोग buy करते रहता है every time something, some products you buy it. Okay, you buy a product, then along with this, अगर आप जाकर ट्राउजर को खरीदी किया, only trouser will not buy, right? Along with you may buy a shoes or you may buy a shirt also. शर्ट का साथ टाई भी कर सकता है. ओके, टाई और शर्ट का साथ आप शूज भी ले सकता है, शूज का साथ सॉक्स भी ले सकता है. ओके, सो मेनी थिंग्स यू बाय वन गो. ओके, वैसा मेरा अगर इसमें मुझको 6 लोग ए बाय किया, all 4, 6 one by one different store maybe, or single store. There's one store is there, you go buy a trouser, along with trouser you buy a shirt. Okay, so he will buy along with trouser he may buy a shirt and tie. Okay, somebody will go, they will buy a trouser, shirt and shoes and socks. Like this everyone buys here. Okay, now इसका साथ मैं क्या करता हूँ, now this is a transaction 1, transaction 2, transaction 3, transaction 4, transaction 5, 6, like the millions of transactions are there. Now I take these transactions and analyze. Okay, now let us take, I have 5 items in my store. Okay, 5 items in my store. Okay, trouser, tie, shoes, socks and shirt. 5 items are there. Now I wanted to know which items are going hand in hand. Together कौन सा जा रहा है. Okay, first मैं क्या करता हूँ, out of 6, let us take only 6 transactions. 6 में मैं क्या करता हूँ, I will pick up 1 item first. Okay, like a trouser I will pick up. So out of 6, how many people bought a trouser? I will have a threshold. Threshold is minimum 3. Minimum 3 transaction में वो trouser होना चाहिए. I'll check his transaction, all transactions. Let us take you all bought a trouser. 4 have bought a trouser. I'll pick up that. Okay, trouser is occurring most of the places. Now trouser का साथ क्या चल रहा है? I'll make what a trouser with tie. Okay, when I use a trouser with tie, all 6 people might not buy, right? Okay, only I have still threshold 3 minimum. So only 2 people have bought a trouser with tie. Then I will remove that. Okay, no problem. Then I will tie with what? Trouser with shirt. Okay, who bought a trouser? Along with trouser also they bought a shirt. So maybe 5 people might have bought a trouser plus shirt. Then I will take these 2 items because they are more than 3 times. Occurrence is more than 3 times. So now along with the trouser and shirt, what other item is happening? Okay, what other item is happening? Trouser plus shirt plus tie. Maybe 2 times only happened. Only 2 people have bought trouser plus shirt plus tie. I'll take out. Trouser नहीं जा रहा है, मैं trouser और shirt का साथ नहीं जा रहा है tie. Suppose if I buy, अगर सबका पास सभी लोग ओके ट्राउजर शर्ट विथ शूज अगर 4 लोग बाय किया तो मैं समझता हूं आउट ऑफ 6 पीपल 4 पीपल आर बाइंग ट्राउजर ऑल्सो, बाइंग शर्ट ऑल्सो, बाइंग शूज ऑल्सो. Okay, now let us take a socks you are not bought it. At least now I know out of 6 transactions, 4 people are buying trouser, along with trouser shoes, along with trouser even shirt also. Now what I will do that, buy one trouser, get one shirt free. Or buy shoes and trouser, get one shirt free. मुझको पता है लोग ट्राउजर तो कर रहा है, शर्ट भी बाय कर रहा है, शूज भी बाय कर रहा है. I know shoes is very costly. I know trouser is also costly. Okay, so I'll combine these two together. Buy one pair of trouser, one pair of say 2 pair of trouser, 1 pair of shoes, get 1 pair of socks free or maybe a shirt, 1 shirt free. क्योंकि पहले पता नहीं था बिजनेस को. जब मैं start digging data, okay, now I know that yes, these are the combinations which are going hand in hand. अगर बिजनेस को पता था तो पहले कर रहा था ना वो लोग. Why that DMart or we can say that Reliance Present every week, every month they are changing the designs. आज आप गया इधर आपको ये फूड आइटम्स मिल रहे तो कल उधर मिलेगा, क्योंकि they are doing some analytics. Okay, अगर मैं this can also help me to design my shelves here. Trouser का साथ I know that these are the 3 items which are going in hand, trouser, shoes and shirt. What I will not keep trouser in one place, shirt in another place. I don't want to divert your attention from trouser to shirt. I'll keep hand in hand together. Trouser था इधर भी trouser भी रखता हूँ, shirt भी रखता हूँ, shoes भी रखता हूँ, क्योंकि more people attention on that only. This also helped me increase my business. This information also helped me to design my shelves. Okay, so this is part of a data mining. I am finding unknown information. That's what it's called a KDD process. We call it KDD. KDD means knowledge discovery from database. You have a huge amount of data. Now you are discovering knowledge. Okay, you are discovering knowledge. What is knowledge on which you can take a decision? Knowledge means you can take a decision. अगर आपको knowledge है तो आप लोग decision ले सकते हैं ना. अगर मेरे पास कुछ भी knowledge नहीं, उसका bottle में क्या है, am I take a decision to drink a water? No, definitely. Okay, that's what I compare knowledge is equivalent to gold. Okay, एक किलो गोल्ड के लिए कितना टन्स ऑफ रॉक्स आई हैव टू डिग? एक just to get 1 kg of gold, I have to dig at least 100 tons of water, rocks, mud, sand, all those things, then process. Okay, then I get hardly 1 kg of water, gold. Right? So it means that I have billions of records to get some knowledge out of that. Okay, now to understand which items are going in hand, I have to go through 100 or billions of records to understand. Just to take a knowledge which items are going hand in hand. That's what it's called, a knowledge discovery from data which is heavy. Data which is heavy, which is data mining is used to retrieve unknown information. And also I compare knowledge, it is like a milk or a vegetables. आज तुम्हारा डेटा साइंस नॉलेज है, फ्रेश है. ये नॉलेज का ऊपर आप डिसीजन नहीं लिया, दिस वेजिटेबल बिकम अ स्पॉइल्ड. इट्स लाइक ए मिल्क, मॉर्निंग फ्रेश है, इवनिंग जाएगा. आपका डेटा नॉलेज, मशीन लर्निंग नॉलेज है आपका, Spark knowledge है, big data knowledge है, Python knowledge है. You have to utilize, you have to take a decision. कहाँ जाना पड़ेगा मैं immediately up to this particular course. ओके अगर आप वेट किया चलो यार थोड़ा अर्जेंटीना और एक बार देखेंगे मैच बाद में देखता हूँ ऐसा नहीं चलता. योर नॉलेज विल गो डिमिनिशिंग. ओके इसलिए नो वन बिकॉज कंपटीशन वर्ल्ड में कैसा रहता है आपका जैसा 1000 लोग रहता है. ओके सो दैट्स व्हाई. सो नाउ कमिंग बैक टू हियर. सो मशीन लर्निंग इज व्हाट one of the things now today we earlier it is called a data mining which was worked with only say structured data. Today the same terminology we made it as a machine learning. Okay machine learning there data mining में भी हम क्या करता था we have to train the machine, we have to train algorithm, we have to give a validation, we have to test it, everything we used to do. So here we are because of data is huge, the same concept as what put it as a machine learning which is branch of computer AI. Which is branch of what? AI. Machine learning is a branch of AI. AI is a branch of computer science, and deep learning is a branch of machine learning. Okay. So now this machine learning, yes, before we machine learning is also part of a OLAP, front end part. Okay, it's a front end part. Back end part both hai. That's what yesterday and day before yesterday, whatever you have seen, it's like a back end part. You have to, you cannot pull data as it is and start machine learning, right? Okay, you have to do a pre-processing here. That is what we call it as a ETL process, where we are going to filter data, you are taking out unwanted columns, you are introducing new columns, you are converting some data type. Okay, all is part of a pre-processing. Some data may be having a null value. Okay, you may be replacing null value with the some value. You may be finding अगर वो relevant column नहीं है तो आप avoid कर रहे हो column. सब कुछ everything is what a data processing part. Data processing includes what a data ingestion. What is data ingestion? Capturing the data first. Okay, कौन सा source पे data आ रहा है. Example, take an example in case of machine learning or in case of what say telecom industry. अगर मैं decide किया I want to know who are my profitable customers. Okay, कहाँ से source है इधर data मुझको 3 source है minimum. एक source है CDR, call detail record. क्योंकि whatever the moment you take a connection, you start talking to someone else, you are utilizing your telephone. Okay, this is recorded somewhere else here. Okay, that is normally it's a machine generated data which is there in the CDR. Okay, while you're opening an account, when you are taking connections, you are sharing your information, what you are. Okay, first name, middle name, last name, email ID, your household income, your regular income, whether you are corporate employee or whether you are individual customers. Okay, so all you are doing. This is your customer profile data is also there. Okay, now you have one more information. You keep paying bills also every month. Okay, if it's a telephone, you are paying a bill or you may be charging whatever it is, monthly or yearly, whatever it is. So your 3 information is there. So from these 3 data, I want to find out who are my potential customers so that I want to give some discount facility to them. When I want to give a discount facility, then out of 6 people, who are my potential customers? Okay, 3 source hai mera. First, I will integrate this data first. Okay, I will take a data from CDR also. I take a data what type of customers they are. I will also take a data from what say how bill they are paying. यहाँ से मैं क्या pre-processing क्या करता हूँ? I will take out some data out. Okay, there is a business rule. What is business rule? Okay, the first business rule says that so you take a half records, don't take it. Like example, when you are calling to someone else, due to software, due to network, due to hardware failure, your call may not be connected. Okay, so you are not generating any income out of that. Correct? Or partially your data is there, partially data is not there. Right? So those data you take out first. Second, business rule also says that every call that customer is doing should generate at least 10 rupees. Only those calls I want to take it. Okay, एक लोग मिस कॉल भी देता है. Is it generating any income? Though you might have done 100 calls, out of which 90 calls are missed calls. I will not take it, that right? So obviously, those type of calls I will avoid it. Okay, that's what those some missed calls also will take, because it's not generating any income. Some calls are value-added services that every service provider provide you. Like if you call to a hospital emergency main, are you paying anything for that? No. Police station ko, firefighting ko, you are not paying. These are all some value-added services they are providing, you are using. Okay, what business says that take only those calls which generates at least 10 rupees. So automatically these are all data. अगर आपका 100 calls है, अगर इसमें maybe 10 call free calls है, 10 call missing calls है, 10 call आपका not connected properly. Okay, so you take out and 10 calls only 5 rupees you have generated income. Okay, only some 30-40 calls which are generated more than 10 rupees. Okay, now just by using that, I will not decide you are my profitable customer. Okay, मैं कंपेयर करता हूँ डेटा हाउ यू आर पेइंग बिल. अगर तुम इतना तो जनरेट कर रहे हो लेकिन तुम्हारा हमेशा डिफॉल्टर तुम लोग, यू आर नॉट पेइंग बिल, राइट? सो स्टिल यू आर डूइंग गुड कॉल्स, बट ऑन अदर हैंड बिल्स आर व्हाट आर पेंडिंग. Every time my customer care is calling you, please pay bill, please pay bill. You are always defaulters. Shall I consider you as a potential customer for me? Take out that also. Take out that as well. Now, what type of customer you are? You are already given information about you while taking connection. Whether you are an individual employee, your age category also you are given, where are you working you are given, your income is also given. Okay, now my question comes about if I want to target only a people whose age is between 20 to 40. I can target only them only. So that for these people, they need these are the set of people who are age categories between 20 to 40 and are generating good income, also paying bill. Okay, now let me, they all need what internet. So 1.5 GB तो मैं दे रहा है, मैं 0.5 GB extra देता हूँ, क्योंकि I know these people are using more of internet. किसको 0.5 GB I cannot give up people to who are about to what say very old age people को नहीं दे सकता मैं, क्योंकि they are not my targeted customers. Targeted customers are between 20 to 40. They are using more internet. They are watching so many channels. Okay, so their utilization of internet is heavy. Okay, and they are also potential. Give it to some discount. This is what people does. Earlier business doesn't know, na? You people are going to give me a data that. Okay, if you are working as a data scientist, you are like a astrology. हम आपका हाथ दे रहे हैं हमारा, आप दे रहे हैं मुझको भविष्य क्या होने वाला है तुम्हारा. Based on my face reading, based on my history, you are giving me my future. This is the role of data scientist. This is the role of how you are doing using machine learning. Using first you should know ना. अगर मैं ये एप्पल है एग्जैक्टली पैदा करने को क्या करना चाहता हूँ, आई शुड नो एप्पल. अगर आपको एक फॉरेन फ्रूट्स आपका पास लेकर आ गया, आप रिकॉग्नाइज कर सकता है क्या ये क्या कौन सा फ्रूट्स है, किस लिए यूज करता है? यू डोंट नो ना दैट, बिकॉज़ आई हैव नॉट ट्रेन ऑन दैट. हमको पता है ओनली पपाई, पेरू, ओके, मौसम्बी, ऑरेंज, बनाना, ओनली इतना पता है हमको. वो आ गया तो हम बोल सकता है ये बनाना है, ये मौसम्बी है, एक पपाई है, और अलग फ्रूट्स आ गए, जैक फ्रूट्स बड़ा आता है. ओके, सम पीपल माइट नॉट सीन आल्सो दैट, राइट? अगर वो बोला तो क्या है, कौन सा है, कैसा ओपन करने का पता भी नहीं उनको. वी आर नॉट ट्रेन ऑन दैट. सो मशीन को भी सेम थिंग, वी आर ट्रेनिंग समथिंग ना. डीप लर्निंग में आप लोग क्या कर रहे हैं? नो, यू आर ट्रेनिंग लॉट ऑफ व्हाट इमेजेस, देन ओनली इट विल आइडेंटिफाई व्हाट. अगर ये ऐसा आ गया है तो वो हैंड है, अगर वो रेड लाइट है तो वो सिग्नल है, अगर somebody is passing in front of car, it's a pedestrian. So you are already training to an entire machine. You are already training to an entire machine, so that then only what you will be able to recognize it. अगर सबको आपको पता चल गया है तो so 8 9 is 9 suddenly if I ask you will give immediately 9 is 9 9 is 9 9 into 9 is 81 क्यों दे कैसा दे रहा है आप लोग मल्टीपल बाय हार्ट किया ऑलरेडी पता है आपको करेक्ट आपको वो स्ट्रांग नहीं तो आपको पता नहीं सकता if I give that 12 into 8 how much may not be no I will calculate 10 आजकल बच्चे लोग ऐसा करता है 10 कैलकुलेटर्स यूज करता है हम लोग का हम बाहर करता था मल्टीपल टेबल्स यू माइट हैव ऑलरेडी डन 30 40 तक हम बाहर करता था आजकल नो टीचर टीचेस मल्टीप्लिकेशन टेबल क्योंकि हमारा नॉलेज ऑलरेडी है मैं क्या करता था मोमेंट आई गेट ए इनपुट आई विल इन्फर द स्कीम आई विल इन्फर द नॉलेज आउट ऑफ माय व्हाटएवर आई नो ओके इन्फर एंड गिव इट टू यू दिस इज व्हाट 9 into 9 is 80 immediately I will give because somewhere else I have trained same thing I am training the machine also. Same thing I am training machine. So that's what first we do a data integration, then data cleaning and transform some data from one format into another format. When I am transforming the data, missing value I am taking out, introducing new value. Okay, introducing new value, introducing new attributes, introducing new taking out some data also. All we are doing as part of machine data processing. Then we have a model training. Okay, when my data is ready, now what you want to do? Okay, what you want to do? Okay, whether you want to do clustering, whether you want this till data processing is a common. Till data processing, like before model building, it's a common. Now what you want to do? Whether you want to prediction, whether you want to say classifications, whether you want to know that other things, that all you can decide. Depends on your what machine learning domain you want to have. Okay. Then once you decided whether it's a prediction or classifications and all, then first step is what you train the machine with the data set. Okay. Agar aapka millions of records hai to almost we divide data into what 3 sets, right? One is a training set, then validation set and testing set. Okay. Training sets are usually heavy. Okay, first we have to train it. We have to train the machine. Then we have to test it. Okay, और testing होने के बाद then हम validation करते हैं. अगर validation का साथ when you are validating your data, still your learning curve is increasing. It means that some more data you will give. Okay, आप train कर रहे हैं. Train तो किया आपका, but it may not be trained properly. But अगर जब टेस्टिंग पे दे रहा है तो आपको 90% आपका गलत दे रहा है डेटा इट्स एक्सपेक्टेड दैट ओके एटलीस्ट 50-50 is okay but if 90% is telling a wrong answer then you may retrain it okay retrain your algorithms and all so here this all what training testing validations all we do then once you are selecting one of the model then you go and implement. This is what a regular process we do as part of what a machine learning. So if you see that real-time Spark, how you do it, the first, everywhere we use a Spark. For ETL purpose, we use a Spark. Okay, ETL means extract, transform and load. Extracting means data coming from different sources, we extract it. Transform means we are transforming the data from one format into another format. Okay. Like that may include introducing new columns, introducing what, taking out some columns, taking out unwanted rows and all. So we do it. So we can do either through the RDD or through the structured data transformations like data frame. We can do either through RDD or through the data frame. We can filter data through data frame. We can filter data through an RDD also. We can filter, join or aggregate or removing duplicates. Okay, all we do through both what is that with the RDD and with the structured data, that is a Spark SQL. Both way we can do it. Okay, we can explore it. Various functions we can invoke for performing the task. We can explore entire data set. That's the exploration part. Okay. Then if you see here, bottom layer everywhere, it is a RDD. Bottom layer is RDD. Top level, you are creating a structure here in data frame or data set, you are creating a structure. But that's part of what? RDD. See, RDD do not have a data frame, but data frame has a RDD. Okay. So now, after processing here, so it comes to a machine learning part. In machine learning, I think you know that future engineering can do, parameter tuning you can do it. Okay, testing, you divide your data and all you do. Okay, and finally, if you want to use any front-end tools, okay, there are so many visualization tools are there. So here also, of course, Python has so many plotting and all, so many visualization functions are there. So you can use it. Earlier days, if you see earlier days, we never had this kind of plotting software and all those things. So we used to process, then we used to use a front-end tools like Power BI or not Power BI, in another tool to visualize your data. But today, most of the tools are supporting with this all. Most of the tools are supporting with this all. Then you can visualize your data and all. That's what we do in machine learning part, right? So now, same thing they have taken here. Yeah. So Spark ML is a Spark machine learning library. PySpark has a machine learning API in Python as well. That's what you can have. And there are some libraries like Spark mlib and spark.ml. So these are anything? You want break?
Yes.
Two minutes. So here, these are the libraries. Spark mlib is used for what? RDD purpose. Spark ML is used for a data frame. Today, okay, I said we are working with only data frame. Today, if you go to a Spark ML site, okay, Apache core Spark ML, they are all, disconnecting or discontinuing with the previous libraries. Today, we use with the Spark with only machine learning part. So usage of Spark ML is recommended because of data frame. Like usage of Spark.ml is recommended. Why? Already I told you multiple times. These are the two libraries they are providing. One is Spark.mlib is they are providing. That's with the RDD. You can perform all machine learning operations with RDD. But nowadays, no one is going to use RDD. Okay, nowadays, most of the things are used through the data frame. So for data frame, we use what is Spark.ml library. Spark.ml library, which is used for a data frame API. So even they have given you that usage of a Spark.ml is recommended because data frame API is more versatile and flexible. Okay, it's more. Why it's versatile? You can change your columns name easily. Okay, then RDD and all. Because ML is new supported pipeline based on data frames and is easier to construct practical machine learning pipeline. You can build a pipeline, one pipeline which has all part, which has this entire process, right from data ingestion till deployment. One pipeline you can prepare in which we can call each and every functionalities. Okay. So now this all we have seen, like transformations, like whenever you want to perform any task, we use like the ML pipeline. When I say a pipeline, okay, so pipeline is a input as a data and output as a model, usually, right? So you input the data, I give us some data, and I will ask you to predict based on this. Predict based on this. So your data is simple input data. Then your output is what? So these are the set of what? Prediction. So that in that pipeline, you have a transformer. Okay. So you have some stages like a transformer. Then you have an estimator. Transformer and estimator you can have. So when you use a transformer, you are transforming the data. You are transforming the data. When I am transforming the data, like filter, all those things, you do it. And take that data. Okay, if you see even this particular diagram, you have a raw data, and I think you can see the same data I am taking, and some of them are changing here. Okay, this, when you are transforming the data, here we have only 3 columns. If you see this particular diagram, you have only 3 columns. After transformations, we are adding one additional column. Some additional column. Or you have a 3 columns. After transformations, you may bring into 1 column. Okay. If you see, a transformer takes a data set as an input and produces an argument data set as an output. For example, tokenizer is a transformer that transforms a data set with the text into a data set with the tokenized words. Tokenize means distributes, right? So now what happened that you may read of 1 or 2 columns, you may split into multiple columns. Okay, so estimator, what it does, first fit on the input data set to produce model. You have to, whatever data, whether the data is a fit for the model, okay, so which is a transformer that transforms the input data set. So whatever you transform, whether that data set is fit for the further process, so you can use. See here, the logistic regression is an estimator that trains on data set with a label and features and produces a logistic regression model. Whenever you want to perform a logistic regressions, I think you know that different types of learnings. Okay, supervised learning, unsupervised learning, and reinforcement learning. Supervised learning में हम क्या करता है, डेटा भी देता है, हम क्लास भी देता है. Okay, we give a data, we also give a class. That's a target variable. That's a class variable, we give it. Okay, that class variable, the data is a independent variables and class is a dependent variable. So this is depending on what say class variable. So now if you take a few observations, like 10 observations. So 2 data, 2 variables. One is a spend variable and sales variable, and 10 observations, like 1, 2, 3, 10. Observation 1, spend 5,000. For spending 5,000, I am selling 7,000 rupees. For spending, let us take a spend means like you are spending on the sales. Okay, sales, spending on the sales. So if I spend 5,000, you sales what? 10,000. If I spend 7,000, sales might be 15,000. Third observation, you might have spent only 10,000, sales might be 7,000. Like this, you give a 10 observations, and 11th observations you are asked to predict. Okay, that what usually use a form like y equal to a plus bx. It's what different you may observations and all. A equal to, for me it's super easy, is for a equal to a, sorry, what is that? X equal to a plus y equal to a plus bx. Okay, so for given b value and x value, I want to predict a y. Okay, so now here I think to find out a y, to find out a x, to find out a b, there are so many statistical formulas. Okay, you find out x value and you find out b value, pass those 2 parameters, find the y value. Okay, so that's what you do it. So here, that estimator, what it does, that logistic regression in estimator, that first we train the machine on data set with labels. With label. These are the data sets, this is the expected output. These are the data set, this is the expected output. Now I'll do a data set only, expect a output. So that way we can do in machine learning as well over here. Okay, so now, as I said, a pipeline. Okay, so you have a pipeline here. So before we start this pipeline, we can take a quick break and come back over here. Okay. So it's at 10:21, 10:20, 10:35. लोग आप भी कहाँ से? हाँ कौन के लिए बोला अच्छा काल केले का तिकडे अंडी कसं आहे अंडी
खोटच वाटतं लोकांना लोक लग्न देख सकते हैं कॉम्प्लिकेटेड है ओके हाल ना पटपट हाल नहीं की रुक ना हाल की अबे जस्ट में नीचे मेरे रूम में नहीं मैं उधर ही छोड़ के जा रहा हूँ तो तो दे कम से कम इधर देखा हूँ इधर नीचे रहते हैं नीचे फुल हम उधर से देखा बस चल
Yeah, one column, what is that? You are doing an extra part. And now estimator is also part of a pipeline. Okay. So you are just taking some columns and you are aggregating it, maybe reducing output. You can see that transformer takes a data set as input and produces an argument data set as output. Means it reads data, maybe a raw data it is reading, doing some processing and generating some output. Okay, like a simple example is the tokenized functions. What do we do that? We read a data, we tokenize based on what's our requirement. An estimator must be a first fit on the input data set. Whatever the data is being estimated sent by the transformer, it should be a fit, okay, to produce a model. Like what type of data required for, see, you may read a data, but does the all data required for a model? Okay, so that's what you can decide through the estimator. Okay, so in some cases, you may need to categorize the value. Okay, you may be having a different countries. That may be a categorical value. You can make it as 0, 1, 0, 1, something. Those things you can do over here. Now, you can see that pipeline. Okay, so this is a pipeline. In one pipeline, data is coming from external source. First, you do a transformer part, then you do a second transformer, then you do the estimator. Okay, and after estimating, you deployment into the model. So these are all setup stages. Okay, stage 1, transformer 1 means basic transformations you may be, validations you may be doing. Stage 2, maybe another advanced validations you may be doing. Okay, so pipeline chains multiple transformers and estimators, each as a stage to specify an ML flow. This is considered as a one stage. Stage 1, what it does. Stage 2, what it does. Stage 3, what it does. These stages are run in order and input data frame is transformed as it passes through each stage. Now, you may read suppose sometime you may have multiple data sets. You may transfer as a new data set, like a new data frame. That new data frame, again, you perform some task, you may perform another data frames. In each stage it does. Output is a data frame. All transformers and estimators now share a common API specifying the parameters. You can pass parameter for all things. Evaluator evaluates model performance. Okay, you can evaluate the model performance. The evaluator can be regression evaluator if you are evaluating your regression model, or binary classifications when you are using a classification problem. Okay, suppose you are yes or no. Okay, prediction is different than classifications, right? So prediction means based on a given value, you have observations, you are giving a next value and you are predicting the probability value, not exact value, maybe a probability. Okay, then you have a classification means based on a data set, you are already given what a data set along with the classifications. You already have data, some parameters you are given. Based on these 4 parameters or whatever parameters, you are classifying the data. Okay, example, I think say wind, like temperature, rain. Okay, let us take wind, temperature, rain. These are the 3 parameters. Whether not, wind, temperature and sunny. Rain is a classification. Yes or no. If the wind is certain speed, the temperature is certain high, if the sunny is this much, so rain may not happen. Like this, you may have what different observations. You may yes, no, you may be having. They are all what classifications or target value you can say. So those things we are giving as part of a transformations here. These stages run in order and multiple data frame is transformed as it passes through each stage. All transformers and estimators now share a common API specifying a parameters. You are passing parameters. Evaluator evaluates the model performance. Okay, one is a regression evaluator. It evaluates the regression model. Multi-classification, binary classification evaluator is another evaluator which you can use for binary data, yes or no, or 0 or 1. Or you can also go for a multi-classification evaluator for a multi-class problem. So you may be having a multiple classes, not one. Maybe multiple classes are there. For that, you can use a evaluator called a multi-classification evaluator. Now this is a common things. Flow में हम क्या कर रहे हैं? First you load a data, then you prepare a data. That's called a tokenizer function we use. Then we use some hashed frequency of data. Okay, this is part of a transformer part. You are transforming the data, right from loading data and converting into certain format. Then you apply estimator. Okay, in estimator, you are calling a logistic regression model. And this regular regression model, then what it does, it evaluates whether the output which is there, how far this output is. Okay, that's an evaluator. So load tokenizer hashed till here is a common. Okay, whether you take load data or test data, so you load data, tokenize, hash is a common. Then depends on your model you select. You can go for that estimator and evaluator. Okay, so in one stage, you are training the program, training your machine in this first part, loading data and evaluating. Second, you can test the data. Whatever data you have, remaining data, you can test on that one. So this is, I think, it's not irrespective of Spark. I think this is generic flow you follow, right? In generic flow, what do you follow? You first load a data, you prepare a data, okay? Then you apply a model. Okay, so here these are some technical terminology we use like estimator and evaluator. Now they have given some data here. Okay, so analyzing NBA data using Apache Spark and Python. Okay, PySpark. So what does this have? Let's analyze some basketball data and make some predictions. Okay, so there are set of data. I think I don't know whether this data set is there or not. Like this one. So like seasons underscore data.txt file should be there. Okay, I should have these data sets. Otherwise, I don't know where this data sets is there. If at all I want to create, we can see here where they are calling several required libraries. Okay, then they are creating a Spark session. They are building a Spark session because Spark consists of Spark context, then SQL context, then Hive context. Then we are preparing a data frame. Data frame equal to spark.read header equal to true, infer schema equal to true, and this is a file. We are reading this data. So this data has this information. Player is one column, POS is another column, age is another column, team ID is another column. Okay, these are the 4 columns in this. Because here I am not segregated column wise. That's what everything comes under only one column. That's what C0. Okay. Now how to make, I know that this data is delimited by comma. Okay, what next? What is the additional part I have to use here? What is additional part I have to use? Suppose if I see now, have you seen this output how it is? Okay. See, I am reading what seasons underscore data. Season underscore data has this information. First column is a player. Second column is a POS. Okay, third column is a age. Fourth column is a team ID. Okay, now G can be a player name. GS can be a POS. MP can be a age. Okay, some data is here which are delimited by comma. Now, here in this, I am creating a data frame. Okay, I am inferring the schema here. Okay, I am also, first column is heading. I am going to skip first row as a header. Okay, but now if I want to segregate each value, if I want to assign to each column, what I have to do here, dot option separator comma whatever that semicolon. Okay, so in that case, we use, say, this type of data here. Okay. Now, here what are we doing? We are sorting this data. Now I know that there is a column called year. There is a column called player. Age is a column. Okay. So I think that is the actual data set. Year, player, age, points, and FG3A. And this is what a data actually. What they have done, they have created a data frame using pandas. Okay. When it's using panda, it's a plain Python. Using panda means a plain Python. Okay. Then it is same as your whatever you have done. Whatever you have done, like Python. Now, after that, here what they have done, they are grouping the first, they are sorting the data here. Previously, order by clause. Okay. They are ordering data. Okay. They are ordering data that in ascending order they are performing, ascending equal to false. Limit, they are taking only 10 records and converting into a panda data frame. Converting into a panda data frame. I think they have put what this only, Python code only here, not a Spark code. Okay, even Python also, you whenever you are going to create a data frame, that same you use, right? Now we are sorting the data. Now here next is what we are, that whatever DF we have created previously, that DF dot order wise, DF is a data frame. That data frame we are using, they are, say, FGA underscore FY is a new data frame that equal to group by year. Then you are aggregating, then selecting only one column. Okay, so this is all what the data is there. Have you worked this quite often in Python in your when you are working with the Python with the data science? Then you are using a plotter and all those things you are doing this part. Okay, now by just referring this, coming back to a Spark, just now I have shared one file to you. Okay, one file to you. So this file, I will explain you. You can do a practical and also we can do together practical also using Spark. Okay, okay. This is actually a, you know that whenever you go to Goa, okay, they will give you bike, right? You can buy a, you can just take a bike on rent. Okay, bike on rent. Let us take, there is a bike center in which they are, okay, they are giving you bike on rent. When they are giving on bike on rent, so every day they have to keep some stock always. Okay. Now, if you want to buy a bike, one is if you are a user, frequent user. Okay, now you can be take a subscription from them and you can be a hire bike. Otherwise, you are only occasional users are there. Whenever you go to that particular place, then only you hire bike. They are normal users. There are two types of users. One is frequent users who are subscribed one. Other one is a normal users. Okay, who will buy bike this one. Now, here request comes. Okay. Based on my previous data, how many bikes I have to keep on stock for casual users and for registered users. Some of them are registered. Okay. Some of them are casual. Registered means when I registered always means I'm going to use the always bike. Okay. And casual means I may go once in a year. Why should I register and pay certain fees for them? So I can, whenever I go, I can use it. So these are the two types of users. Now, here, if you look into, these are all observations. Okay, observations of each day. Okay, each day. Okay, how many of them? How many of them are there? Like example, if you take first observation, like instant one. I think there are so many records are here. Okay, we can just see around 17,379 records are there. Too much data is here. Now here, first observation, first 1/1/2011. Season, they have one some code, like a season 1, 2, 3, 4, like whatever seasons we have. Year, also they have. Month, in which month they are. Which hour. Okay, it starts with a 0, means exactly 12 a.m. Then 1, 2, 3, 24 hours date is. When I say 20, means it's a 8 p.m. in the evening. Okay, when it is a 22, definitely it is a 10 o'clock, 10 p.m. in the evening. 23 means 11 o'clock in the night. Okay, these are data. This is 1 day data. If you look into this data, till here, till 24 hours data. Okay, when it's a 24 hours data, see this part. That time, some whether is this, some data is there. Okay, whether it's a working day, weekday, or a holiday. Okay, hour is 1, which is 11 o'clock a.m. in the morning. Holiday. Okay, there is some code is there. 0 and 1 is a code. Okay, that is whether it's a holiday or not holiday. Let us take this is a holiday. 0 is holiday. 1 means no holiday. Okay, now it's a holiday. Weekday means the 6th day of the week. Let us take this is a Saturday. Okay, now working day 0, no. Because when I say it's a holiday, it is definitely working day equal to 0. Okay, weather, how it is a weather, how it's temperature. Okay, so how humidity, how is the wind speed. So based on this parameter, okay, casual users, only 3 users have there. 3 casual users took data. Casual users took 3 bytes. Okay, registered user took 13 bytes. And total count is 16 bytes. At same day, 1 o'clock, casual users took 8 bytes. Registered user 32 bytes, so 40 bytes at 1 a.m. in the morning. Right, like this, these are data we have. Okay, every hour data is here. If you see closely, okay, around 5 o'clock, no one is because sleeping. Okay, normally there are 2 types of sleepers. Some people night दिन होता है, दिन को राइट करता है. Okay, there are so many people. Okay, for me I use perfectly. Daytime means no sleep, night means only sleep. Some people are reverse, especially people who stays in PGA or hostel. Friends गप्पा मारते रहता है 12 बजे, 2 बजे, 3 बजे और 4 बजे को सोने का, उठने का 11 बजे के. ओके, वैसा भी रहता है. हाँ, but now you may feel good. It will disturb. It's not a biologically correct. Okay. Sorry, whatever it is, but have a 8 hours sleep, but preferably in the night. कुछ भी है तो आप दिन में करो. 10 बजे 11 बजे सो, 5 बजे को उठो, 6 बजे को उठो, but before sunrise you have to get up. Okay, now, so this is the data. So this is the data of see morning, no, hardly one bike has gone. Till what? Till here, till 8 o'clock. So till 9 o'clock. Okay, again after 9 o'clock से थोड़ा bike increase हो गया. Correct? If you observe it, see here 110 bikes have gone exactly at what time? 3 o'clock. Okay, थोड़ा अच्छा रहता है weather. 3 o'clock bikes. So between 2 o'clock say 14. From here onwards to almost, this is a very good right time to take a bike to roam here and there till 5 o'clock or 6 o'clock. Okay, like this we have so much data over here. Okay. Now I want to, this is they have kept already they have transaction has taken place here. And this was the count. अगर मेरा last में एक so and so date and this all parameter, I want to predict how many is supposed to be keep for casual users, how many I have to keep for registered users. This is my prediction. Okay. Now going back to the one which I have given to you. Okay, is another one. This is what I have given to you. The same is there here. Okay, machine learning using here. So how to create a machine learning pipeline, how to train machine learning model, how to save and read model, how to make a prediction with the model. Okay, the data is, see the data set contains bike rental info from 2011 and 12. 2 साल का data है. Okay, 2 साल का data yearly 24. Okay, yearly कितना date रहता है? Days 365. 365 into 24. Okay, into 2. That many records are there. Yeah. So now there is a company called Capital Bike Share System. Okay, then some additional relevant information is also there. Okay, now that's like a weather and all. So you can keep this file into this area. Okay, now because you can keep that file, now you can read that file also. Right. What is our goal? So our goal is, okay, our goal is what? We want to learn to predict bike rental counts per hour. कितना हम मैं एक नया साल में 31st 2012 2022 को कितना बाइक मॉर्निंग टू इवनिंग कितना every hour I have to keep a stock so that I will meet my requirement. I can, whosoever coming, I will not send back without bike. Okay, I want to predict based on this data. So here, first you can keep your file. What we want to do, we want to learn to predict bike rental counts per hour from information such as day of the week, weather, month. Having good prediction of customer demand allows business serving to prepare and increase supply as needed. So now when I know my people, okay, when I know my people for last 2 years, okay, hourly कितना चाहिए, कितना लोग casual आ रहा है, कितना लोग registered आ रहे हैं, so that in 22 को मैं prepare कर सकता हूँ. Okay, 22, 31st to or January 1st to 15th November, कितना bike I can keep on stock. So first part is what you have to load a data. I told you, you can also try it. Huh? You can first you keep all files into your, together we'll do it. Okay, you keep your files into local disk of Databricks. Okay, so now I'll go to a Databricks here. Okay, in the Databricks, I'll keep a file. Okay, you know already how to keep a file. Click on browse, bring that data, our data here, open it. Simply I open a data which is of 1.2 MB data is there. Okay. So this is my path, right? So note down this path somewhere else. Okay, I'll keep this path over here. Okay, so that I can read this data. Now, first and foremost things, what you need to do before, I can just create one model here. I can create a separate notebook here. Okay, so that notebook is called Bike Prediction ML. Okay, I can create in Python language and I'll attach to a cluster. I think cluster is not yet created. I'll create cluster. Okay, so it is a cluster is not yet created. I can create here also. I can go to compute. I'll double click on this. I recreate it. Okay. So it is recreate, more, clone. Clone means recreate. And take out this name, create a cluster. Let it create cluster. Now, since I have created a bike prediction ML, first part what I need to do, I have to upload a data. In order to upload a data, okay, so there is a here. Okay, first we have uploaded a data here, and I can attach that path to one variable. And I can also, okay, I can also what here, I can also what path is there already. This is my path, which I have downloaded. This is my path. I can replace this path with one variable. Okay, it should be within code. It is actually a path. Path is assigned to in Python, you know that path is assigned to a file name. Now initial df. Okay, now I'm going to read this particular path, spark.read dot option, because there is a header also in that file, CSV file as a header. I want to skip that header. Okay, I want to infer the schema also. Infer schema dot CSV, that file name. And since I'm going to use it for frequently, I want to hold them into a cache. Okay. Now, when I want to hold them into a cache, first run it. Sorry, cluster is here to create. Let me attach. Once a cluster, it's created, now automatically it run it. Okay, can you also do it? First you upload a data. Step by step you'll understand it. It is, I think in some places I need your support also, because some of the machine learning terminology you people use here is there. You can understand that. Okay, now I'll go to a next here. Okay, now let it create, let cluster get created and we'll start. Quick, I have only 1 hour now. Run this and finish it.
Can you share this code on the chat?
I have shared. Achha, one by one I have to share. Okay. Step by step I have to share. Okay, then I can share that anyhow. Okay. Is that okay? Okay. Because this file also it is there, you can take cut paste from there also. This is what I know, lesson 18. There also it is there. Okay, now before let it start, meanwhile, I'll explain something about the data. So as I said, we have a data right here. Okay, data, if you look into this, we have loaded a data here and we are going to count approximately how many records are there. And also we want to see the schema. Right, this is what we will execute once our cluster is ready. Now we'll see, this is about data. Let us understand the data. Okay, if you want to download this data, you can download from this site also. So what are the data here? One, the first is a DT day. The first column is there here. In this case, this is the first column. Okay, I'm explaining each and every column here. So first a DT day is a date. Season. Okay, season has some value. Okay, there are 4 seasons. 1 means spring, 2 means summer, 3 means fall, 4 means winter. Okay, I think in this here you have only 1, 2, 3 something. Okay, now 1 means what? A spring. This one spring. Second, we have a year. There are 2 years. Year 0 means 2011 data. Year 1, if it is a 1 having value, it's a 2012 data. Right? Second, month. We have 1 to 12 months. Okay, 1, 2, 3, 4, 5, up to 12 months. Hour. 0 means starting of the hour. 23 means ending of the hour, like 11 o'clock. Holiday. Whether the day was holiday or not. Okay, whether day was a holiday or not. Weekday, day of the week. Which day of the week? Okay, now if you see this day of the week here, holiday, whether holiday or not. Weekday, which day of the week? Obviously, it is 1 to 7, right? 1 to 7 should be the 0 to 6. Okay, 0 to 6. 0 means Monday. 6 means Sunday. Now we have working day. Working day is a working year 0 or 1. Only 2 values are working. 0 means not working. 1 means working. Now weather list. Okay, weather it. So here about weather, we have some values. 1, 2, 3, 4 values are there. 1 means it's a clear, few clouds are there, partially cloud and partially cloudy. If it's a 1 value here, okay, if it's a 1 value, means few clouds, partially cloudy, this is our data. 2 means mist plus cloudy, mist plus broken clouds, mist means mist plus a few clouds mist. Some the data. 3 means light snow, light rain, thunderstorm. Okay, some scary data is there. 4 means heavy rain, ice pellets. Okay, I think you can also just see that if it's a 4 now, there may not be a bike gone because people won't take a risk to go on rain. Okay, that's the data here. We have only this one of these 4 values are there. Either 1, 2, 3, 4. That's a weather list here. Okay. So if you see a 4 now, I think there's no 4 here. There's no 4. Very few people go to 4th reason. Season 4th. 3 is there, okay. 4th is windy, rainy, cloudy. That time there may not be a value. People may not go. Temperature. Okay, here we have normalized temperature in Celsius. The value are divided into T minus T underscore minus. Some this a formula it is there. So some temperature value is here. Okay, only in hourly scale. You know, in that means maybe a temperature second to second may be changing, but hourly what is that average temperature they have? A temp is a normalized feeling temperature in Celsius. Okay, normalized feeling temperature, that is humid. Okay, humid has a normalized humid. The values are divided between 0 to 100 is a max. Okay, humid value is being divided into 0 to 100. Wind speed, normalized wind speed value between 0 to 67 is a max speed. So these are the values we have. Okay, as part of the input data. Based on the input data, we have some labels also. So here labels is a casual count of bike for casual users, count of bike for registered users, and total count. Casual plus registered total kitna hum prediction karna chahiye. That's what the count of total rental bikes including both casual and registered users. Okay. Now here there is a one more column is there. That's a like row number 1, 2, 3, 4. Na? They are called an observations. Okay, we call it an instance. Okay, that's an instance here. Extraneous column is a instant. That's a record index value. Now, what do we need to do? For example, the first row is record is 0 on January 1st, and last record is a 16 people rented bikes. That's what we have given example na? On bike on 1st January. Okay, there are 16 people who have taken a bike, of which 13 people are registered, 3 people are casual users. Now, after this, now the first step, we have to do a pre-processing, right? So once you are pre-processing, already we have uploaded data. Okay. So recall our goal, we wanted to learn, predict the count of bikes rentals. Means I want to know, predict how many counts I have to keep. Okay, with respect to a label, that's a direct counter. So there are some features. Okay. So there are few, all columns expect CNT, the few exceptions are there. Like we have a casual and registered users. The CNT column is a number of counts. Casual plus registered. That's what CNT has, a casual plus registered count. Okay. Now there are some, the season and the date column, DTD. We could keep them, but they are well presented by the other date related columns like year, month, and weekdays. Because season is not related one, is depending on month also, which month, which year, which weekday. Holiday, we have holiday and weekday. These features are highly correlated with the working days. Holiday and working day. Working day people don't go for a biking. Holiday maybe a more people. Okay, it's holiday, but also weekday. There are two things. There are some week holidays like Saturday, Sunday, and today is holiday, but it's working day. It's a weekday. That's a weekday. Like आपका Wednesday holiday मिला. That's a weekday, but it's a holiday. Okay, impact है. One है, people may target only on Saturday, Sunday, और people casual users में क्या करता है? चलो आज Saturday, Sunday घर में रहेंगे और वीकडे कुछ अचानक एक हॉलिडे मिला, चलो जाकर आएंगे. These are casual users. Okay, so that's what here we have some values here. Okay, now what I need that I don't need an instance 1, 2, 3, 4 instance. I don't need that because that's a part of data, but I don't need that. Date also not required. Okay, date also what not required. So date, I don't need a date. Okay, I want to know that in this particular day क्या चाहिए. Okay, so here what we want to do, we don't need a date, season, casual, holiday, weekday and all, we don't need. So, and also we don't need and users. Total count चाहिए तो मुझको ठीक है. Okay, total count. If I need some of the data which I don't need, every minute data, okay, so that I that will not be much contributed for my decision. So those columns I can take out. So how do you take out columns? You use usually a drop. Okay, now what I do, I'll take this one, I will drop it. Okay, I'll go back to here. I think by this time it might be created. Here, it's running now, cluster is running. Now I will run this command first. Control enter. Okay, it's connecting to a cluster. Okay, it's connected. Now I can see how many records are there, and schema also I can decide. I can just check it. So there are here number of records are schema has done, right? Okay. Take out this and run only one command. 17,379 records are there. If I want a schema, I can also find out a schema here. Okay, this is my schema. So I said I don't need an instant column. I don't need a DTA column. I don't need some other columns also. So those columns we can obviously drop. So by using a drop command. Okay. So if I want to drop it, what is that? Here, I can drop this one. This is my dropping. Here, you know that already how to drop. Initial DF dot drop. So these are the column instant, DT day, season, casual, registered. I don't need this because this is not, I can take a total count na. बाद में कितना लोग जाएगा लेकर जाएगा, but this I'm not specifically deciding number of count of bikes for casual users. No, total counts कितना चाहिए, how much total count I can keep. Okay, I can drop these columns. When I drop these columns, so I can just simply I can take out these columns and okay, so I can pre-process the data. Okay, here we can pre-process the data. After pre-process, okay, once I pre-process, you can see the schema. Okay, earlier schema was different. Now this schema is different now because after deducting data, so you have a small schema. Year, month, hour, working day, weather list, temperature, ATM, humidity, wind speed, and count. So we have taken out all columns. So we have created what a new data frame. Okay. Now after removing this column, required columns, some of the data you have to even transform. Okay. So now we have transform here. Then this data, totally 17,000 data is there, right? So first what we need to do, we can divide the data into sampling. Okay, sampling हम कर सकते हैं. अगर testing को कितना, train को कितना and all. So here I can just, I have a data, pre-processed data is there. Totally, randomly I want to split into 70 and 30. Okay, so that is 70 will go to what? First one. Okay, the first, this parameter will go to train DF and 0.3 goes to a test. So it means that that's what totally we are splitting, okay, into 70 and 30. Seed, what for seed is being used? Random. Okay, random. We can use a random. You can just take out this random seed. Or I don't know what is this. So the same thing. So you can just simply run it. So you are divided into 2. So again, I have to come back to your place. Here. We are calm. Okay. So now, after this, you are divided into, say here. Now I can just check it records, number of records. Okay. Train df dot count. अगर चाहिए तो कर सकता है. And we have a test data. Test df dot count. दोनों आप कर सकता है. जो total record 17,000 records are being divided into these two sets. Okay, that is 514 is I think test data and count. Count. Why it is not coming? Let us take up first one. Last is executing. If the 12,000 records are there in the train and 5,000 records are there in the water test. Okay. Now we have divided the data. After dividing this data, right, now if you want to print, you can print the data that we have done it here. Okay, we have print the data. We have total number of records. Train is 12,000 and 5,000 plus 12,000 plus is a train and 5,000 plus is a test. Right. Now, if you see this data, there is some correlation. Correlation is what? Total count is there. Okay, there is a count is depending on your weather also. Count is depending on your temperature also. Count is depending on even in which month you are taking the bike. Count is depending on whether it is on working day or holiday. Count is depending on your humidity also. The correlation is there. Na? अगर अच्छा holiday भी अगर holiday भी नहीं working day but weather is pleasant, I'll take a bike and go. Okay, so there is a correlation between count versus week, wind speed, month, working days, humidity, and temperature. Now you can just check it. अगर आप देखना चाहता है तो अगर आप you can use this display command and see the relation. अगर for testing purpose, if you want to just check it, okay, you can just see the relation between these two variables. Just take this test. Display is a command in Databricks I use. Display. Otherwise, show also I can use it. Display is somewhat cute. You can use this command just to the temperature of this data. I think easily you can see here. I can use show also. Spark we use a show. Year, month, hour, week, day. Oh, now we can just correlation between count versus these all three. Okay, count versus wind speed, count versus humidity, count versus temperature, count versus weather list. Okay, count versus working days. Okay, count versus water. Say hour also, month and hour. So you can just have a correlation between these all data. I think agar aapko here there's a simple this one is you may not visualize here actually. Agar aap visualize karna chahta hai to, so I think there should be actually proper query should be there. So from this we may not visualize it. Okay, so there should be display whatever data is it just displays, that's all. Nothing else it does. Okay, so after visualize. Okay, now what I can do here next, after identifying the correlation between these three, okay, you can say if you go through that data interpretation, if you can do it, rentals are low during the night and they peak in the morning 8 a.m. in the early evening 5 p.m. 5 p.m. if you see this data, 5 p.m. data and night and check it. Night means 00, sorry. Our 1 is, this is only very 13, 22 are there. Right. When you go down here, okay. Here also what is that? 1 a.m., 2 a.m. Okay, 2 a.m. also data is less rental. And evening 5 you can see, or 8 o'clock also you can see. 6 o'clock. If you see you are increasing, sometimes 7 o'clock increasing the data. Okay, then if you again 9 o'clock, no. 8 o'clock, just check it. 8 o'clock is more data here. Okay, 8 o'clock, there will be more rentings are there. And early night, 5 o'clock. If you see 7 o'clock, 17 means 5 o'clock. Again, more rentings are taking place here. Right? Evening 5 o'clock भी ज़्यादा renting जा रहा है, और evening सुबह 8 o'clock also there will be. That's the, you can say, rents are high during the summer and low in the winter. That also you can see that based on the data, we can at least analyze the data. Rentals are high on working days versus non-working days. So there are more rentals on working days and not in non-working days. This indicates the hour, month and working days features all are useful, can help us to predict the count. Now I know that there will be a morning 8 o'clock heavy bike rentals are there, evening 5 p.m. heavy boats are there, winter season is there. Okay. Okay. These all we can at least rough prediction one can do it based on that. Right. So you know that these are all what are kind of a numerical columns. Okay. And some kind of what are categorical columns are there. What do you understand between numerical columns and categorical columns in regularly?
Data types.
Numerical columns are all are having a numbers. Categorical columns we have a
Gender, column, female,
male, country names. Okay, country names, gender. Okay, male, female, like this. So these are all categorical columns. So these columns you can convert into numerical values. Like wherever gender is there, you can 0. If it is not present, it is something 1. Something you can say gender. Like I have a gender column. Okay, I can have a gender male and female. Okay, wherever male is, if this record male appears 1, means this is a male data. If it is a female, if it is 1 and 0 under male, so it will be female data like this. So we can categorical columns are year, working day, and weather list. We would treat both month and hour as a categorical, but we could lose the temporal relationship. So if I consider they are as a categorical column, if I consider, then obviously we lose the actual essence because they are already categorical columns. Sorry, they're already a numerical columns. Here we have 2012, 2011 something, and working day, yes, no, 0. Already it is there already. If I convert them now, okay, so we may lose its value and all. So in that case, what we can do is we can create an indexer. Okay, indexer is between 0 and 1. Okay, so for each of the categorical assumption is that they are the categorical column. We can create a categorical columns, okay, using a string indexer function. Okay, so string indexer function, what it does, so you can use input column, that's whatever weather list or something, and you will create a weather list indexer. Okay, your output column is what? Your input column. Okay, and your output column. If you use input column like a weather list, so you will get output like a weather list index. Okay, whatever number of you give it, so that you can give it. So this will have an effect treating the value like a weather list is not as number 1 through a 4. 1 means light, mist, medium, heavy. So then that kind of you can, instead of having this value, so you can just simply convert into 0, whatever that value you have. The same way, other column is also there. Weather list is there, and we have working days. Working day also we can convert into categorical value. So to convert this, in order to convert them into a string index value, string indexer value, so we have to import one of the library called from PySpark.ml.feature import string indexer. So for indexer, you have to import here. Then we can convert straight away whatever columns you want to convert. Like working day, if I want to convert, so working day indexer equal to string indexer, give a input column, give output column. Same thing, working day index, we are using that working day indexer equal to string indexer, working day is input column, working day index is output column. Okay, that way we can perform. Suppose now if I want to convert over here, it will create an additional column. It will create an additional column over here. So now when I go to this, okay, so first of all, I need to import required library. Okay, then I can convert them into what? Input column, string indexer. Working string indexer is the name of the column, and input column is working day. Okay, output column is a work indexer. You can just write a command and just simply run it. It converts one index column over here. Now, if I want to, this is just a variable. Instrument ML code with the ML flow use. This is what they are giving. Don't show this again. It's just because they have in latest they have included one ML flow application with the Databricks. Latest, maybe 2-3 months back they have included. This is a new feature of Databricks. So don't worry. So now we are just simply converting into indexer column. Same thing. We can also, we know that there are three variables we are going to convert. One is, the first one is working day. Now, if I want to just check that particular column, so I can simply just check it whether it's converted into indexer. Okay, working day indexer dot fit. Now we are going to use to this indexer. I'm going to apply it to where train DF. Okay, and that we are going to transform. Okay, that transform train DF, and that we are going to print. You see, this is just a column we have made it. Okay, this I have to attach to what a data frame. What is the data frame? We have a train DF. Okay, so automatically these additional columns are being added into that. Here, this is nothing to do any data frame. We are not creating any data because working index or working holiday is just a column name. But we are not attaching to a data frame. Here we are attaching to a data frame. Working string indexer dot fit. It fit to this train data frame, and also transform apply to a data frame. Now, when I run this, it is part of a data frame now. Okay, it's part of a data frame. What is in data frame here? Train data frame, we have year, month, working day, weather list, temp, all are there. In addition to that, we have one more column called working day index. Okay, I have a train data. In that, I will attach one indexer column, like a categorical column I will assign. If you want to just see data, you can also show, or you can say display also. Okay, you can use this much only. I can convert into a display. Display over here. So you'll see that one more column here, this working index column, additional column it is there, 0, 1, 0. It converts into one of the value between 0 and 1. So it will be as part of this. So in the same way, otherwise your working holidays, we have only this value. We are converting them into a assumption. This is just because already we have a 0, 1, 0, 1. But in this example, we are assuming working day is a categorical value. We are converting them into index value between 0 and 1. In the same way, we have other two values also, like year is there, 1. And we can also have a year also. Go back to this. Here convert into per year also. Okay, so if you want to see output, you can see output of that. Where is this? Yeah. Here, year. If you want to see the print scheme of that, you can also print this, because the additional column is there. Okay. If you just see that one additional column is there applicable to year index. Okay, and same thing with the third also. Same. Yeah, third is a year, working, and weather list. Third. weather list. If you want to print that as well, you can just print also. So here what we have done, we have converted them into what a categorical value. We have a columns. So assumption we made it as a converted into whether a sit index is a new column which is being added into a existing data set, that is train df. So after adding as a this one, here we make it one vector. Okay, did you use a vector in your this one? Python?
Yes.
What for it is used?
Almost one word.
Huh? Vector. In the categorical value, here we are using an indexer. That's what converting categorical value. Sorry? Which one? That's what indexer. Here we did indexer. Converting that text value into numeric value. Here we made an indexer. Already. Huh?
How many direction of the values?
What for vector is used in your Python? Did you use a vector?
Vector we use NLP.
Vector assembler. Huh?
Each one is different and that one is different. Both are different.
Okay. But till here that categorical value understood? So here holiday, year, okay, some temperature. These are the columns already we have 0, 1, 0, 1. But here we are assuming that they are the categorical value. Okay, we are converting them into a 0, 1 value. Okay, because using that is a string indexer in Python. We are converting them into a index. Already they have 0, 1, 0, 1. But agar all some categorical value hai, so like cold, wind, sunny and all, we can convert them into a indexer value between 0 and 1. Now vector here, the next step is to assemble the features column, okay, into a single feature. So there are so many things are there here. Now we are bringing under one umbrella. Okay, that's called here vector. We have input columns, output columns of 3 columns. Okay, so now we made it individually earlier. Here, this is an individual part, right? Individually we have seen. But now all we bring together one. That's called a vector here. Assembling all indexer into one. So that if I pass that, it will be there one only. Rather passing 1, 1 here. So far I have passed only 1, 1 here, right? Here. This is also only working days I have made. Here previously we have made something about temperature. Working day we have made. Then year indexer separately we have made. Okay, now what we do that? We bring them into one. That's called an assembler. Assembling. Right. So this is what this input I can pass. I can, instead of passing single input, I'll pass all inputs together. What is that? Assemblers here. Assembler inputs equal to month, temp, HR, humid, a temp, wind list. Then indexer. All together. Earlier I made it 1, 1. Now I'll bring into 1. Right. So means that in assembler we have all required columns along with the indexer. Okay. In this case, we have to import one again ML library that's called from PySpark.ml.features import vector assembler. So vector assembler is means you are bringing isolated variable into single. Did you get the point here? What I did it? In this case, I have tested only one. Okay. Agar aapka, I have executed first also. I have executed this also. When I executed this, it shows only one column. When I execute this, it shows only one column. Here I execute this, it shows only one column. Okay, suppose if I make this. Okay, when I enter this column, it's showing only one. It's not showing all other two. Okay, here only weather list is there, not humid and all. Here, whichever, when I executed this part, here working days only. Second, I have list here. It is only with the string indexer year only. In this case, only year has converted. In here, we have converted only this weather list. But now assembler means these three variables along with the data sets together. That's called an assembler, we call it. So that assembler, so rather bringing individually, we can make so that I can pass one parameter. Okay. So here we can make one parameter. That's assembler. Not, this is not an assembler. Okay. When I go to this together assembler, what is that here? The next step is to assemble the features column. Feature column is categorical columns into a single feature as a single. Rather passing isolated columns, I'll pass only one variable which has all columns as a parameter. Okay, that parameter called, to do this, we use a vector assembler where we have some input columns and we have an output column. Input columns are many, output column is one. That one means all columns. That is what here, if you go to this, assembler inputs equal to, what is the input here? Month, temp, HR, humidity, temp, wind speed, year index, working index, weather list. All we are using as an input. So that's what is an input first. Output is what? Output COLS equal to features. These are all inputs. These are all what? Outputs. So only one column I can use as a parameter. So now when I go here, okay, so I'll make this as an input. If you see this, okay, assembler means I'm assembling all columns as a inputs. Then vector assembler. Okay, vector assembler equal to what? What is that equal? That means input columns. Input column means this, all columns. Output column means features. Okay, so only one output column, all of with many input columns here. One input, many input columns and one input column. You are rather passing every one by one. I'll pass set of inputs as a single. Now, what for you is a random forest? In your case, random forest, what for it is used?
Binary class.
For binary and multi-class classifications. Okay. So here we have label column. Okay. That's what our point. CNT, count. Count is my label column. So there already we have some data is there in my observations. But now I want to classify into binary class. So that is why here we are using a random forest. Okay. So how it is random forest? For that we have to import a random forest regression algorithm. Okay. So random forest regression equal to random forest regression function set label. Our label is a count. That's a target column. Okay, I think you know that set seeds 25, set number of trees, depth, how much depth you want to go, and maximum depth is 10. How much you can, when you are going to classification, you prepare a internally graph, right? Okay, to this graph, again, you further you graph. So you can see the depth. Okay, up to 10 level. Till 10th level, you can go for a depth. So here, when you go for, you can just random forest, you can use it. Okay, so you can call this particular function and you can go for a RFR. This RFR means I can pass as a parameter to my data. I can pass as a parameter to a data here. So now we know vector assembler, we know that random forest for classifications and all. Then we use you put into one pipeline. Okay. So how do you do that? If you go here, create machine learning pipeline. Now we know that assembler, we have all multiple inputs into one column. Then we have a random forest where I can classify target columns. Then let us create a pipeline here. Okay, in order to create a pipeline, so this is the from PySpark ml.import pipeline. So now pipeline equal to, if I want to create a pipeline equal to pipeline function dot set stages. Then first we are using a working day indexer, weather indexer, okay, year indexer, then vector assembler here. Vector assembler means all set of columns. Because we have created vector assembler in the beginning, where we have a lot of columns. Then we are also passing parameter as a RFR, random forest regression, where we can also mentioning that okay, you can go to certain depth. Okay, that parameter we are passing, and for that is a pipeline we have created. This pipeline, now you pass any data. Okay, you can pass any data to over here. These are the 3 parameters we are passing. Okay, now we have created a pipeline. A pipeline ko aapko input data chahiye, output kya chahiye, that we can make it. So first, now our pipeline is ready. In the pipeline, we know what is your input structure, what is your categorical structure. So we have made it as an assembler. Then we have also made that categorical this vector assembler, all columns which are required for decision making. We have grouped under vector assembler. Then also we have for target column how to do a forest random regressions, that also we have given. Now we have to train this pipeline with trained data set. Okay, this is what here. Okay, now simple, because already pipeline is created, just I pass a data. So when I train this data set, okay, I can just go and train this data set, which is already there. Okay, here it's already there. Okay, this pipe model which is created already here, pipeline. For this pipeline, I am passing trained data frame as a data frame as an input to a pipeline. So automatically it takes this care of pipeline, creating a training part. Now you want to test it. You want to evaluate it. No? So in order to evaluate, once you train, after evaluation, so you can use one random forest regression model. I think there are multiple random model, random regression model. So you can invoke them for evaluation here. Since it's a random forest regression model we are selecting. So what you do that? Random regression model, random forest regression model equal to pipeline model. This is what here, pipeline model, which has this data. Pipeline model dot stages -1. So this is what random forest regression model is, the last stage of the model. So we can use and we can identify the score of that. Okay. So now I can just simply pass this. Okay. This is the last part, because I am going to train here. Then I want to evaluate here. Now I want to know the score. Okay. To find out the score, okay, I think you can see this there's one more. Over here, you can scores equal to zip assembler inputs. You are passing assembler input means all columns. Random forest regression model. Okay, and you are passing these all features. For this, you can see the score. Okay, and how to see the score? There you can just go back and just check it. This percentage and all. Okay. How is the score of the data? Whatever the training has made. This what for X in scores, because score is being stored into this. Okay, X in, because there is a one loop is there. In Python, you use a loop, right? For X in scores, print whatever the score. This is a score. Each column score you can see. Okay, each column score you can see. This is overall. This is each column score prediction is there. But now, if you make everything together, is a total score. Kitna percentage aa gaya aapka? So they see with respect to month and target value 0.025 score, temperature ke liye 0.38, 53% hour ke liye, okay, 19%, okay, like that multiple just score of each column, and each column score you make it as a one your data and apply to entire data set. Okay. Now you can see this part. If you want to deploy and evaluate, you can just take this and you can also evaluate. Okay. Now the same what is pipeline you have created. Now you are passing a test data and prediction you are making. And this prediction, okay, you can go and just check it here. Reorder the columns for easier interpretation. Otherwise, if you want to interpretations properly, how evaluation is there. So you can what a prediction, you can just see it. Evaluation, just here you are not doing anything, just whatever output is there, that output you are predicted output you can see here. Like count, prediction, year, index value. Now you can just see the output. You can just analyze. Prediction is total of each column prediction. Each column prediction, each record prediction. Okay, so this is your total prediction of each and every record. Okay, another total prediction code. How do you make a total prediction? Summation of all. Okay, that's what next is what evaluate it and sorry. So we use okay, root mean square error. RMSE we will use here also same thing. RMSE use it. So evaluate with the regression evaluator. Regression evaluator is there. So for that regression evaluator we have to import, and count is there, set label count, regression evaluator, and RMSE evaluator. We can see that what is the accuracy of your accuracy means 100 minus error is the accuracy. Okay, so you can just how much your model is accurate. So you can just you can do RMSE functions. You may get something around RMSE is a 79.86% of your. So almost 80% is your accuracy. Taking 20% errors. Okay, you can this way you can make it. So this is what how you are performing machine learning for prediction. बाकी आप लोग को visualization क्या करना चाहते हो आप? You can use a clustering. Okay, you can use a. This is about a linear regression. So if you want to do, you can do even this. I will just share with you. This is totally working. export DBC. आप लोग पाइथन का चाहिए तो पाइथन का भी शेयर कर सकता है. Anyway, it's a DBC file is get created, and I can go to a download. Sorry. So you can just, अगर आपको चाहिए तो ये भी कर सकते हैं. What is that? I have given to you, right? It is forwarded. कैसे करने का इधर आ गए क्या भाई? प्रेडिक्शन ml.dbc. अब आपको पाइथन कोड चाहिए तो वो भी पाइथन कोड भी एंट्री कर सकते हैं इधर. Where is this? I want to take this, export into IPython notebook. Okay, IPython notebook is there. IPython. You can use that also. Okay. Now this is all about what how you perform machine learning. Is there any difference between your regular machine learning and this machine learning?
Yes.
There are some additional libraries you have to import.
Yes.
Okay. And this is that Python may be supported only for small amount of data because only one machine is there. अगर आप real time scenario को गया ना, so you can have as many machines you want, as much data you want to bring. Okay, and the calculation is much faster because of more machines are involved, and it's in-memory technology. Everything is being interconnected with the in-memory, so no need to read the data from any disk. Okay, so this is what I think. Based on this, I think same thing they are using only a Python code here, ना? वो Python code है हमारा, वो Spark code है. Okay, so just they have given this all part how to use here the and that is what how already we have seen practically also how to use a machine learning. Okay. Okay, quick in 5 minutes. What all things right from beginning we did it. We started with Linux. It's an operating system, multi-user operating system, multitasking operating system, and after Linux. Okay, there are some shell called a Bourne shell. Okay, Bash is a shell in Linux, and we have seen so many commands of Linux. Okay, those commands are file system commands, directory commands, file commands, some utility commands, and all. We have seen architecture of Linux also. Innermost is a hardware. In between we have a shell. Then we have corn shell. Then corn shell we have. Then we have an application, then utilities and application. That's an architecture we have seen, and we have seen a commands. Then we move to a big data. So big data, we have discussed generic big data is a collection, is a process of dealing with volume, variety, velocity of data, which can be processed and analyzed effectively, efficiently, and economically. In big data, we know that there are a lot of unstructured data, less amount of a structured domain. You can use any domain big data like banking, retail, manufacturing, and all. You can use it. Then you can use. There is a platform to process big data. That is a Hadoop. Hadoop is a platform to process big data. So within Hadoop, two major components is HDFS and MapReduce. Okay. So MapReduce used to process the data. Hadoop is HDFS used to store the data. We know already how it stores the data in the form block size is 128 MB by default. Then in order to ingest data, we have used two ingestion tool. One is a Flume and Kafka and Scoop. Okay, so Kafka can be used for real-time data. Scoop, Flume can also be used to pull a data from web server, and Scoop can be Scoop can be used to bring data from RDBMS, or you can push back into a RDBMS also. Then we have used Pig and Hive. Pig we have not covered. Hive is basically used to process or analyze data. But at backend, what they will do is just simply it converts into a MapReduce job, and MapReduce job is being executed at backend. Okay, then we have seen equivalent to a Hive. Okay, that's a Spark. So Spark is an in-memory technology. So in-memory technology, so which is much faster. Code is very minimal, and you can execute with a high fast and all. It's an in-memory technology as such. So it's almost 100% faster than MapReduce. So we have seen an architecture of formal Spark also. We have a Spark master and Spark workers. And this, if you look into a very high level architecture, we have core Spark and Spark ecosystems. So core Spark, which is very close to hardware, in which we are going to work with the RDD, resilient distributed data set. When you create that's a fundamental unit of Spark, where we have to create a data RDD, then only we can perform on operations. So we have created RDD, we have seen few operations like action operations and transformation operations. But in RDD, we don't have any data structure. Hence, we move to one ecosystem that's called a Spark SQL. So Spark SQL is used for extracting data from bottom layer with structure. So that what data frame equal to data structure plus RDD. Okay, we are extracting data from the bottom layer, but with structure we are extracting. Okay, and when you create a data frame, the data frame, difference of data frame between Spark and your pandas, that is a single data frame. On single node data frame is there. So this data frame is scattered across multiple nodes here. Then we can move different operations again. Operations are divided into two types, action operations and transformation operations. So we have seen filter. Okay, then we have used cache, persist, then limit, order by, sort by, okay, or various important transformations we have seen on data frame. And also action operations are like show or display, count. Even if you want to save, you can also use the save. Okay, that's the one ecosystem. And then using RDD, using data frame, we have used another ecosystem, that's what machine learning. So using machine learning, all machine learning operations you can perform. Only one operation, the linear regression, which I have shown you. Like you can do a clustering, you can do prediction, you can do even ANN, artificial neural network, all you can perform. I think when you go to, I think the one which I have shared with you, I think you can try. Okay, you can try when you go to your Spark here. I think there are set of machine learning here. You can see linear regression is there. Linear regression 1, 2. We have decision tree. Neural network is there. Okay. So even K-means algorithm, all algorithms are there. So you can just try on this machine learning on Spark. So that will definitely help you to learn machine learning on Spark. If you are stick to this, you know machine learning, you know Spark, and using Databricks platform, okay, तुम लोग को आराम से place हो सकता है. Don't stick to only machine learning and Python. क्योंकि आपको थोड़ा cloud is a cloud-based tool है. Okay. Now, even if you tell any company that I have worked machine learning on Python also, I have worked machine learning using Spark, using Databricks platform. उनको वो लोग पता चले बंदा को मशीन लर्निंग भी चाहिए क्योंकि आप लोग ऑफ कैंपस है. अगर ऑन कैंपस है तो वी डोंट एक्सपेक्ट दिस. ऑन कैंपस मुझको पता है कॉलेज से आ रहा है बंदा, उनको पता नहीं कुछ भी. Now I am taking raw talent from the market. That's the college. We cannot expect they have an experience. But when you are going with the off campus, people expect, yes, you are aware of these things. क्योंकि ऑफ कैंपस है आपको, ऑफ कैंपस है तो तुम्हारा साथ 2020 का भी आने वाला है, 2014 का भी आ सकता है कॉम्पिटिटर, 2021 का भी आ सकता है. एनीवन कैन कम ना, ऑफ कैंपस में कोई भी आ सकता है. सो अगर जब आप इधर इफ समबडी सम कंपनी कम्स हियर एंड ट्रेन यू, अगर वो ऑब्वियसली अगर डेटा साइंस है तो तुम लोग मशीन लर्निंग काम किया क्या, आप बोल सकते हैं मशीन लर्निंग तो आप एक्सपर्ट है. देन आपका कौन सा प्लेटफॉर्म यूज कर रहा है वो पूछ सकता है, तो पाइथन, जस्ट पाइथन, स्पार्क भी हम यूज किया, डेटाब्रिक्स प्लेटफॉर्म यूज किया, तो वो लोग को इमीडिएट रिक्वायरमेंट आता है. डेटाब्रिक्स इज वेरी हॉट, ऑब्वियसली इट्स हॉट. Okay, with this, I am closing my session. If any questions you have any time, please, anyway, mail ID is there, mine. So you can just send a mail with reference to whatever this batch. Okay, so I can help you wherever. Anyway, I have set up mail IDs of you all. अगर हमारा इसमें कुछ आता है तो, अगर ऑफ कैंपस हमारा हमेशा रिक्रूटमेंट होता है, दिस ईयर 22 में या 23 में, आई थिंक 24,000 हम रिक्रूट करने वाले हैं, with college hire and without college, and especially women के लिए ज़्यादा है gender diversification. So because of that, so we are doing so many things. So अगर मेरा आपका mail ID है, I will, if any comes with us, okay, we keep getting mails. अगर आपका refer करो, okay, अगर normally we don't refer, so usually हम mail भेजेगा आप लोग. This one, if you register, so and if you are matching to a requirement, so they will call you directly. Yes, obviously there are a lot of requirements. Okay, you can, अगर आप मुझे तो इधर through this you can join, और later also switch करना चाहता है तो let me know, I can help you wherever I can. Okay.
Thank you. Thank you.
Okay then, yeah, I have to rush because 2 o'clock I have to leave from home. मैं ट्रेन हूँ. ओके, अगर चाहे तो मुझको कभी भी फोन करो एंड आई कैन हेल्प. ओके गाइस, थैंक यू वेरी मच दोज हु आर इन ऑनलाइन. एनीबॉडी इज देयर? 9881297741. हाँ, उनका पास है. जस्ट गिव मी अ रेफरेंस ऑफ दिस बैच.
हाँ, ओके.
मैट्रिक्स अदरवाइज. हाँ, PGA32. या. Okay, I think no anyone is there here in the.
Yes, sir. Shailesh is there.
Shailesh, I am leaving. Thank you. So I can stop it. Okay, so anytime you can contact me, I will help you. And for even for advanced